Okay, we'll get things started on day 2 here, and we're going to sort of do a couple of little exploratory uh, things using some a little bit better uh, drawing content than just drawing a couple of, you know, sticks and circles and things. So what I want you to do is go ahead and load up your Carlson software, and then we're going to open a file. And that's going to, prompt you to find a file. So navigate to where you have stored your data sets. It should put you back there from your last session. If not, just where you stored your data. So I've got mine in this data sets for fundamentals class that I put in my 2024-0530 class folder. And you should see a list of files like this, one of which, this first example, was one that we were playing around with yesterday that we made new. Um, so some of those may or may not be there in yours, but you'll see probably civil demo and sample from T3 global.dwg. So let's go ahead and open this civil demo.dwg and take a look at what's in that one. So I'm going to select that and choose open. That's going to go up. Now, it's a fairly simple file. Got a small subdivision, and you can see, um, stream, center lines, roadway center lines, and edge of pavement. You've got, right-of-way boundaries and lot lines and things like that. And they're not exactly, like this white line around the road, that's on a layer called lot lines. And then this purple boundary around the road, that's actually not a right-of-way line. That's the perimeter or the footprint of having built that road at its vertical design. So we got some things in there like that. Lot numbers, houses and such, tree lines, some contours with elevation labels. So it's pretty simple drawing, but we're going to use it to learn a couple of tools here that we're going to look for. So one of the first things that we really should be doing whenever we get a file from somebody else, and this would represent an effort like that, like maybe I'm going to take this file and either do some more design on it, or going to need to evaluate what this file might contain to make sure everything is correct. So I would normally do things like, well, let's see, don't really know, if this has been drawn to the proper scale or not. So I would check something like, I would just measure the distance across um, edge to edge across the road. So I might go up to my inquiry menu and find this standard distance command. It's going to prompt me for a starting point, and I'll just go from, say, any place on one of these, um, the edge of the roadway here, the right of way line. I'll just grab that corner and I'll measure. I can either just measure straight across to that corner, or I can even, um, do this shift right click and choose perpendicular snap to uh, missed something here. Do a distance. Okay, so now from here, um, and do a perpendicular snap to the other right-of-way line, and it comes back and reports 50 units or 50 feet. And if you know anything about this particular subdivision, that might be, well, okay, that makes reasonable sense that that's a 50-foot right-of-way. So, all right, so it looks like they're at least scaled in the right direction. And what else might I do? I see labels on my uh, contours. So I might check to see if those are drawn at elevation, because sometimes they are and sometimes they're not. And I can see some things here like every contour line's labeled except for these two down here, making sure that there's 838 up to 841. So 39 and 40 should be those that should be okay. And I might check the elevation of, one of these. So I'm going to select the contour line and look at its properties over here. And I see, okay, that's 838. I also am going to see that it says polyline and it doesn't say 3D polyline, which would indicate they would have differing elevations. I can also tell that by the shape of the grips. When I select a 2D polyline, I also get these midpoint grips as well as the vertex grips. And if you hover the mouse over those, of course, you can do things like add a vertex or convert it to an arc, that sort of stuff. So that's just CAD work on the grips. Now, so, you get a sense of what you're doing here. You might also say, well, let's look and see what what layer did they put the contours on, for instance. So maybe you'll select a contour and you see, okay, it's on a layer called topo. Probably makes sense. I might select one of these lot lines and it's a line on a layer called lot lines. There's a building, 2D polyline, but you see it also has an elevation. So it looks like they gave me floor elevations and it's on a layer called buildings. So, as you go through to try to analyze what's in this file, you got a lot of things that you can do with just some standard um, CAD tools and things like that. But let's learn some of the other quicker ways of doing some of this, especially when you have a much more complex drawing. So one of the things that you might want to verify is, here, for instance, is what looks like another building, you would think. Um, who knows? But it's on a layer called trench. Well, maybe it is a trench, but it's a rectangular structure. So maybe that's supposed to be on layer building, and you know that, so it might be drawn on the wrong layer. Uh,
Ken,
yes.
on that rectangle that you just
Uh-huh.
that's situated right planned south of 104 and 105.
Right here.
Mine says looks like V stream pond, like Victor stream pond. Is that what you have? No, yours says trench.
Yeah, mine says trench.
Hmm.
The stream pond, huh?
So I was thinking. So initially I was thinking, oh, that must be like a basin or something.
I've
Hmm.
got the center line going through the contours over here as stream. Well, that's interesting. These
Hmm.
stream pond. Well, here's something that you can check and see. Now, you have the very same data that I have. We downloaded the same file.
I do.
You got these spot elevations up here in the upper right.
Okay, I'll double check that one moment. And by the way, that center line,
Hmm.
just to the left, excuse me, west of 105, mine is labeled like Victor River Center. So I guess like the center of the river.
This
Um,
here.
let's see. Yes, let's see. It just may be showing up a little different in the with the AutoCAD engine
No,
underneath. Let's see.
no,
10.
yeah,
Did you say check the spot elevations in the upper northeast corner?
yeah. You have these spot ele Oh, you know what? I know exactly what's going on.
I do.
I know exactly what's going
840.
on.
Oh,
Your civil demo, it's the same file name. Now, I opened my civil demo drawing from my data directory that I downloaded the demo. I'm betting you opened, and I'm going to go ahead and open this from here, a file from Carlson Projects, which is one of the built-in. So I'm up here at Carlson Projects, and
oh
it also
no.
has this civil demo. It's okay. It doesn't have any, it's not a problem. So if I look at that, yeah, see. So now
Okay.
when that comes in, cursor comes back after it loads.
Come
Now,
on,
if I
give me a
look at
second.
that, I select this and I see that's on V
Yep.
Stream Pond or
Okay.
Storm Pond, rather. V indicating survey, and I've
Mm-hmm.
got buildings that are on V building outline. Yeah, see, these are using the national CAD standards. Um, so they've sort of updated this drawing since the other one was made and put in your data directory. Okay.
All right. We'll get to the new one. I had ended it anyway. Doesn't matter. I will go to the other one.
You also see they've taken out the footprint of the roadway too. They've taken that away. And they've also added this lot line back in between 78 and 79. So they've done some repairs to this as a sample file.
Mhm.
Um, but that's the one thing I really like about the other drawing is that it needed to be fixed in a couple of places. It was a good teachable moment.
Mhm. All
If,
right. And I'm back online with the correct demo now.
okay, no problem. Yeah, so here's a couple of things. Looks like the only thing with elevation are the contours and the buildings. All right, so hey, let's come back to this guy. Yeah, so now you can see these layers are just sort of, they're a little bit more generically named, and they're actually a little, possibly a little bit more meaningfully named. The other with the V dash and C dash, it does indicates from that national CAD standard. Anything starting with a V dash would be a survey based layer, and a lot of people extend that even to say if it starts with a V dash, it's existing, because that's where you get your existing features is from a survey. And anything with a C dash is a civil discipline, and it's usually indicative of it being um, a design output. So, um, so in that sense, they have a little bit better control on that kind of stuff. Yeah, see, because this original, notice there's a lot line missing between 78 and 79. Um, and it's got these other things like this footprint of the roadway from when it was created. So, but anyway, here's where we're headed with what we're looking at now is we're trying to identify a couple of things in the drawing, and if some of the CAD techniques and some of the things we do is like we usually select an object or multiple objects. Let me come here, say, and select, um, a couple of contours, lot line, and a building and a driveway, for instance. So I've got those items selected, and I look over in my properties and I see I've got 5 items selected, which I have 1 line and 4 polylines. And if I choose line out of that pull down, I can see that, okay, that's the line that's on layer lot lines. If I say polylines, I see, well, the building outline and the driveway and the contours are all polylines, but they're all in different layers because it says they vary. My layer varies, my line type varies. Okay, so um, that's one way. If you need to gather up a bunch of different things and put them on a common layer, you could do it that way. For instance, when it says varies, you can still change those and put everything that you have selected in this pull down up here, you can put on a particular layers sort of thing in the property. So all of those types of things that we're doing here are just plain old CAD properties, and it doesn't make any difference. You can make your edits and changes and your inquiries that way. You know, and I do that quite a lot. I look at properties quite often to help me analyze the drawing. But like I say, if you get a particularly large file, let's say in this file, I can see my building outlines, and I looked at one of them, I saw that it had some elevation to it. It was non-zero, so it was elevated at some point. Um, so they're probably drawn at say, a finished floor elevation would be my guess. But, I'm not I'm not necessarily convinced that they're all on the same layer. Now, they do have the same color, so that would be some indication that if they were drawn with a color that was known as by layer, and the layer definition for that building outline was red, then that's probably okay. But if I wanted to see whether or not all of my building outlines are on their own layer, and also maybe to see if there's anything else that might be drawn on that layer. I'm going to come down here in this lower left. I'm going to grab that rectangle and I'm going to show you an example of how this might happen. So I'm going to turn that on and I'm going to, I see that that's on layer trench. And I may even make that, let's make it yellow or a different color, whatever it is, instead of just by layer. We're going to make it a specific color. So it's on layer yellow and it's on trench, or even if the trench layer might have been red, it could show up and not necessarily be one of the buildings. It could be by mistake on a different layer. So if I'm going to put that building, I want to match it to be that same layer as the building. I might select a building. I see it's on a layer called buildings. I hit escape, clear the selection. I select the yellow one. I see it's on a layer called trench. Okay, I'm going to come over here and pull that down and choose buildings. And now I've put it on buildings, but it's still yellow. Okay, so that should tell us that, all right, let's go back and look at the color. This building is on buildings as a layer, and it has a color that is known as by layer. So whatever that layer is defined as is the color that's going to show up. So this one then, if I look at that and I said, well, I just changed that to be on the layer buildings, which I did indeed, but it has a color that is specifically yellow, not by layer. So if I switch that color to be by layer, now I can see, okay, it looks like that would match pretty nicely. All right, so I'm going to now undo a couple of times to where this is now back on trench and it's colored by layer. And if that color, or if that layer rather, trench, I'm into my layer definition, which I chose by view, layer control, and, or, you just run your layers from your layer toolbar. I'm going to find that trench layer and I'm going to make it also red because you'll sometimes see this happen. So now that one was by color by layer, it looks like it's all on the building layer. And so that might, lull us into a false sense of something here. So we need to figure out, well, how, what's a way that I can check and see if that's actually on the right layer or not? And there's really no way I'm looking at this and suspecting that it would be, but it's always possible that any of these building outlines might be on a different red colored layer. We don't know. We want to make sure because a lot of commands are going to be involved picking things based on their layer membership. So there is a command in AutoCAD as well as in IntelliCAD by itself on the layer toolbar. It's called layer walk. It lets you run through things, but the Carlson equivalent of that to me has a little um, different capabilities. And it's on the inquiry menu. So everything we're doing at this stage is we're inquiring about our drawing. We're doing some exploration and finding information out about it. So if I go to my inquiry menu and I choose layer information or layer inspector rather, and this is different from the IntelliCAD or AutoCAD command called layer walk. It's similar to, but it's a different command called layer inspector. Your screen is going to split and you'll get a little panel at the bottom of the screen. Now, that panel is floatable You can even stretch this out. Unfortunately, what they didn't do, and this would be great if they would do it like this and let you resize it, but unfortunately, this little list over here on the left is only 5 lines long, and you can't open that window up. So, in that sense, it doesn't do much for us to have that as a undockable panel. I'm going to go ahead and hit the exit button and go back and have it reset itself back to Layer Inspector. It's down here at the bottom. So I now see those 5 lines of text, and I can't really, inspect. I can't really make it go any further. But so it's going to, close up your drawing a little bit. But now here's one of the differences between this and Layer Walk is that you can still point your cursor up here in the drawing and roll the wheel and zoom in and out, uh, press and hold the wheel, and you can move it around. Okay, but what we're after now is to be able to cycle through these layers and see what's on any given layer or any given combination of layers. So there's a couple of things. We've got all of these little zoom controls, zoom in, zoom out, pan left, right, up, and down. Again, the wheel mouse takes care of all of that. You've got what do you want to do when you choose a particular layer from the list? Do you want to zoom to that layer? Do you want to isolate that layer? In other words, turn all the other layers off. Do you only want to highlight that layer so they just kind of get dashed looking? Or, and then also, and it's pretty important to tell it to restore the view on exit. So once you exit this, it's going to put the view back the way you had it with whatever layers were frozen, etc. So I'm going to choose to zoom and isolate those particular layers. And you see, I've got my current drawing layer, whatever it happens to be, which is layer 0. Okay. It tells you that right there in my heading. If I select that layer, it also says over here to the left, the entity count. You see that line right there. So I've got an entity count of 0 on layer 0. That's fine. Nothing shows up when it did the isolation. Now, if I click buildings, I see all my buildings. Well, now you notice that little rectangle that used to be on layer trench, or that's is still on layer trench, but it was red, and I assumed it was a building. Well, I see it's not there. Now, if you don't want to isolate the layers, you can still, you can toggle this switch on and off. So you can see that building is disappearing when I do the isolation. Tells me there's 14. That's another way I can do that. You can step through these individually. There's my center line layer. Notice they're of different colors. I've got C text. That looks like my contour text. Not sure if they're all the same, but that's one way I can step through these. You can also select more than one layer. So there's my buildings, and if I want to look at my buildings next to my lot lines, I'll just scroll down here with the wheel on the mouse. I'll find my lot lines, and I'm going to control click. So I now have buildings and lot lines, but I don't have the outside boundary. There's a perimeter. Let's see if I can control click that. There's my outside perimeter of my subdivision, but I also see I've got this roadway perimeter. So that's really, I would want those to be on 2 separate layers because I want the overall boundary of my subdivision in terms of lot lines. I want that to be a separate layer than the footprint of the roadway construction. That doesn't, but they're right now, if I come down here and find just perimeter, I'm just going to have perimeter selected. Then that would tell me I would probably be better served to take this outside boundary and maybe make a new layer and assign it to that layer if I don't have one that says boundary. Okay. So in any case, here I've got all of these different features. I can look at these things individually. Um, There's my driveways, for instance. Let's look at that with buildings. So I'm going to control click the driveways. Looks like every house there has a building or has a driveway. If I look at if I unclick my isolate, I say, oh, there's a building that doesn't have a driveway, but I realize now that it's on a different layer. So it's just a means of helping you visually step through what it is you're looking at. But you can also do some further things. Notice you've got a rename button, so you can rename these layers over here. You can erase the entities on certain layers. I didn't really mean to click that, but apparently I got it. So it's now down to see my driveways. If I turn my driveways back on, see, they're gone. I erased them. I didn't. I'm going to undo this when we come back. Um, but erase entities, I hit erase entities, so it now says I have 0 entities there. And because there's nothing on that layer, it is now free to be purged. So I can delete the layer itself with that button. Okay. And then now, once I've done so, which you don't have to, but excuse me, I'm going to go ahead and hit the exit button. And it's going to come back, restore my view from before I went into that command. Well, let's say I need to do a couple of these undos until I get my buildings and driveways back. There we go. So there I've got everything back to what happened beforehand. Right, in good shape. So that's a way of looking at those as well, is with that layer inspector. Now, one of the other things we've been looking at were selecting these items. We look over here and see their elevation is showing up as a property. Obviously, the layer name, the color, that sort of stuff. So we can do that, selecting something, checking its properties, do that sort of back and forth. But there's an even quicker way of doing that as well, also on the inquiry menu. And it's similar to the layer inspector, and it's called the drawing inspector. And notice this is drawing inspector on and off. So if I choose that, it's going to turn on the drawing inspector, and I see nothing happened on the screen. But I see down on the command line right above, it says the inspector is on. Right click to activate a pop-up menu. There's also one other very subtle thing that happened is once you're familiar with it, you can look for that. And that is the fact that the cursor is now not only a crosshair, but it's also that arrow pointer that you're familiar with from typical Windows software. So it sort of combines that, and they sort of don't necessarily stay exactly on top of each other, but they will catch up. But if you right click now, as it told you to do, you have this list of things that you can see in your drawing inspector. So I'm going to right click there. And the one thing you want to make sure that you have is down here at the bottom, you want to enable the tag display if you want it to show up in the drawing area. Otherwise, it's going to just report down on the status bar. All right, so I'm going to look at that. And let's say I'm really only looking for, say, the drawing or the display, the layer name. So I see a couple of checkboxes here. I've got the checkbox for layer name. I've got the checkbox for polyline data. I'm going to select that polyline data and left click it so it turns it off. Now I right click it again and I see, okay, so that's really the only thing I'm going to be showing is the layer name. And now instead of having to click on something and look in the properties, I'm just hovering the mouse. I'm not selecting anything, and it's reporting the layer that is on, okay? If I right click the mouse and choose, all right, well, let's look at the layer name and let's display the elevation of these so I can check the contour lines, for instance. So I hover here over this blue contour line. It tells me layer name topo, an elevation of 842. I look at one of these buildings, and that's a building layer 841.839, 840.449, 840.598. So you see what I'm doing is getting a chance to evaluate some of these options. And I see things like, well, there's the driveways, they all have 0 elevation, so they have not been raised to a particular elevation, right? I can right click that and let's say I'm tired of looking at the elevation and the layer name. So I'm going to uncheck those and then I'm going to come back and say, let's look at the polyline data. So if I hover over a piece of text, for instance, it doesn't show me anything, but if I hover over the polyline, it tells me about the segment that I am hovering over, gives me a horizontal distance. And if it were a 3D polyline, you would see a different number for the slope distance. I would have an elevation at the start and an elevation at the end. I have a slope percent ratio, the total polyline distance, and the current segment distance, and whether it's open or closed. So if I say had, let's just take, I'm going to select one of these and I'm going to copy it. I'm going to just put it down here. And I'm going to turn that into a 3D polyline to show you the difference on these. And I'm going to just going to switch over to my civil menu real quick and go to that 3D data and just choose 2D to 3D by start and end elevation. I'm going to just select this guy and I'm going to give it a starting elevation of say 800. I'm going to go up to 850 elevation. And
Ken, what was that second command on the menu up there in the 3D data?
set polyline to elevation.
Thank you.
Okay. And that's the same as if you just select it. If you select a polyline, and that means a 2D polyline, and you want to give it, let me get just one of them selected here. And then you would come here to properties and give that an elevation. So you can do it that way. There's a little difference in that when I run that command from this 3D data menu, see, it's asking me down here, enter an elevation, and right now it's set at 0. Notice one of the options though says select. So that lets you select. So if I switch it to S, if I choose that as the option, because that's the capital letter there, it says now select a piece of text or any other line work to establish that elevation. So if I choose that 105 lot number, for instance, see what here, it read the 105. It lets me add or subtract values to that. So if I'm looking to see, what elevation to put a water line 4 feet into the ground, I can take 4 feet away from that. And then, all right, so 105 minus 4 would be 101. Let's go ahead and take that default. Now select that. Maybe I'll select this guy right there. And now that one is, you can see if I select it and look at its elevation, it's at 101. So in that sense, it's a little better than, me just going here to properties and looking at elevation. But if I know what the elevation is, that might be the quickest for me. But that gives me a bit more range of things I can do. You've also got a change elevations command, and you can do that by differential or absolute, do it even by a vertical scale, and even change the layer if you change it. So if you're taking a 2D down at 0 and you're going to elevate those, you can keep the original and change change the layer to maybe a 3D break line layer, for instance. Okay. So just a number of different ways to do the same type of thing. But for those of us who don't have the civil module, maybe all we got survey, then we don't have those particular tools immediately available. But all I wanted to do was to now look at the difference between when I select this contour line, I see in my properties that that is a polyline or a 2D polyline. If I select this one, notice there are no midpoint grips, only the vertex grips. And I see in my pull down that it is in fact a 3D polyline. And I might be interested in this as a feature to try to figure something out. So if I want to know, say, what is the elevation of this feature, and it's continuously changing. It goes from 800 to 850 or whatever the numbers were. But what is the elevation of, say, right there in the middle of that one segment? Well, the CAD way of doing that would be to issue a command called ID. So I would come down here and type ID, select a point to identify the coordinates. Well, I would shift, right click, and choose the midpoint of that segment right there. So I click on that, and it then reports that that has an X value of that, a Y value of that, and a Z value of 812.33. All right, well and good. You can get the individual grip elevations, for instance, of all the vertex points by selecting it, get your grips on, and then let the mouse hover into the grip, and then look down on the status bar and read the coordinates out of that little readout down there. That's one way. But what happens in between? Well, that's one of the things that's nice with this drawing inspector. Remember, it's still running, even though I've been running commands at the same time. So it can run in the background while you're doing these commands. And I'm going to, in terms of elevations, I'm going to go back, right click, turn off this polyline data. I'm just going to say display elevations. So I look over here and my contours, they're going to pop up. My building's going to pop up. My lot lines, my text, everything's going to be 0. But now look at what happens here. If I start over here near the end where it's 800, that's 800.115, I'm just hovering the mouse. I'm not clicking. But look at the elevation readout. So it's reading that 3D polyline in real time and reporting back the elevation of all of those individual locations. So if I'm trying to design something around here and I want to say, make sure I've got a good starting elevation and I've got some of these, this might be a feature on the ground. Well, I see, well, right in here, I'm like at 825 and something, and over here, I'm like at 829. So 825 to 830-ish. Or maybe what's even here, I know that about midway or the 3/4 marks, that's at 828. So I may decide to design something and set it at that starting elevation based on that reporting. So if I go back to the right click menu, I'm going to uncheck the elevation, right click menu again and choose display polyline data. And I'm going to also now see the difference I've got on that particular segment, a horizontal distance, a slope distance, the start elevation, the end elevation of that segment, 800 to 803, 879, which is a slope of 6.88% or a 14.5 to 1. I've got a total horizontal distance and the current distance, that's the distance along that it's talking about. So if I'm over here from the start up there is 382.6 out of 726.875, and it's open. You can also right click and say, show me the polyline direction. So that shows you the direction in which the polyline was created. And just these little glyphs are going to show up, just tell you that it started in this particular lot line. It started here and it ended here. So sometimes you have to reverse the direction of a polyline. You can figure out what that direction is without having to select it and go over to your properties and step through the vertices to see which one's number 1, which one's 2, 3, and 4. Okay, so a lot of information that you can get out of this. Obviously, the more that you show, particularly things like direction, then the more, it's going to sort of lag the operation. It's not terrible. But see some of the other things that you can look for. You can look for, let's say, these polyline blips. Those are the grips, you see, and it shows you quite clearly where those vertices are as you hover the mouse. Um, it'll actually, it should be Yeah, there we go. So every time as you hover, see, there's a little bit of lag on the response, at least in this version. Maybe the AutoCAD version is a little quicker, I'm not sure. Um, and then, you can just shift the view a little bit and that will go away. But there's no real practical reason for me to see that necessarily. I can find those out. Curve data, display curve data. I'm going to come up here now and hover over these circular parts of the roadway here. I see I've got a radius of 37.01, an arc length, chord delta, etc. So you can figure out how that's working. If I look at this white boundary, that's my right of way. You see there it has a radius of 50, just like we saw on the distance across. And I get a chord and a delta. Some of these things that might look like this purple circle around here, it looks like a circle, but if I hover over it, it's not really a circle. It's a polyline. If I select it, I can say, oh, that's a polyline with all those individual little segments, okay? And so if I hover over there, it says it's not a curve. If I hover over the white line, it tells me some curve data. Now, one of the things that you may or may not notice here, does that look like a curve to you? I've got a straight segment, a straight segment, a straight segment, a straight segment. Same thing up here, right in here. See that? And I see when I hover that it does have a radius, an arc length, but that's very definitely not a smooth looking circle, is it? Is everybody aware of what causes that? And you notice it now, it does look like it because I did a regen on the drawing, or I had it automatically regenerate. That's a um, that's I would say a feature that's characteristic of AutoCAD files, is that when you have curved data, if you zoom in really tight, and if you don't have your automatic regen set to being on, they start to look like stop signs instead of circles. And it is a result of the way it shows you things on the screen is through a process called display list processing. So it builds a list of entities and figures out let's say I'm at this elevation level, it figures out the minimum number of little things it needs to create to make them look like circles and lines, etc. So at this elevation, it's put enough of those little straight segments in its list of things to display, or its display list, to make it look like a circle. If I zoom in tight, from that level, then I'm going to start to see, let me go back out here first of all and do a regeneration. And let's see I'm going to turn my regen auto off. And so I can show you this effect. All right, so I've turned that off. So now I've regenerated at this level. And so now if I zoom in really tight on one of these little driveway radiuses, you see how it's blocky and choppy it looks? And the only way I can do that, now you're going to not necessarily know when something is a circle or not if you see these kind of things until you get at that zoom level, and you would issue a regen command, regen. Well, if I do that, it turns it back into a circle at this zoom level. So now they look like circles. So if I zoom in really, 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 really tight, you're going to start to see it segment again, but it's still a circle. Okay. So now I'm going to turn my regen auto back on, and that's another um, CAD tool that you can use to where as you zoom in and out, it will decide when it needs to regenerate the drawing. But if you're sort of, not liking things, circles that are always looking sort of blocky, there's a particular variable that you can use, and maybe, take take your pen and make a little note of this or put it in, something if you don't remember. But that particular variable is called view res. Okay, it's a VIEWRES, and then you can just type it as a command. And when you hit enter, it's going to ask you a couple of questions. It's going to say, do you want fast zooms? Well, yeah, of course, we always like fast zooms, we would say. So I'm going to say yes. And it says enter the curve display quality. And your allowable range is from 1 to 20,000. Now, this is a number, this is a value for this particular variable that stays with any given drawing. It doesn't set AutoCAD for every drawing. It only sets it for this particular drawing. The advantage of this was back in the old days when we didn't have much video memory and computers weren't that fast, that if you could live with it drawing a little more stop sign looking circles, it would compute faster and display faster. I mean, we used to have to wait on a screen to finish updating, back in the old days. So we set that number to a lower value, and so that the screen would update more quickly and it would not have to regenerate that often. Um, but the higher we would set that number would mean to us the smoother we want our circles to look. That's the curve display quality. And but the more often it would have to regenerate the display list and take a little bit of our time that way. So that's sort of your compromise. Now, this particular drawing has a really low one. There's no need for that in today's modern age. I like to keep mine always up to the maximum of 20,000. And so now everything is it's going to regenerate more often as I zoom in and out. But as I do that, notice how, I don't see that stop sign looking stuff anymore. I can get so much data in my drawing that I would start to see it at some point, and I can just stop and do a regen and get it back to being a circle. But that's my particular preference. Now, this is going to go back to what we talked about yesterday in the drawing templates. If you have something like that that stores in the drawing and does not store in the system, then you have no control over that until you open up any given drawing and you run that command and see what it is. Well, what about when you start a new drawing? Where does it get that number? What is it set to? Well, it is set to whatever that value is set in the drawing template that you use to start that drawing. Okay. So if you'd like to always have that number high like I do, I go into my drawing templates, I open them up, I type that command, VIEWRES, answer the question, set the number up to that high number, and then I save that template. And so then the next time I create a new drawing using that template, it's going to inherit that value. So that's another good example of something that you want to set in your drawing template if you like it to be a particular value. And there are certain things, certain settings that are stored in the drawing, certain things that are not. And there's a couple of ways to tell when and where they are. In the
Ken?
IntelliCAD, yes, yes, Gretchen, you're muted again. Did you have a question? Hello? Okay. I've lost your audio at least. I don't know if, can you still hear me okay?
I think there was just a glitch. It just came back.
Ah, okay. All right.
Thank you.
Were you getting ready to ask a question or?
No, I guess you heard me ask it. It's like the screen froze and I didn't hear anything or see anything.
Oh, okay.
Thanks.
Yeah, I barely heard the fact that it sounded like I didn't even hear a word or anything. I just heard a noise that sounded like it might have come from somebody. Okay, so yeah, that could have just been a momentary lag on the on Zoom. But anyway, that would be an example of one of those variables or one of those settings that you might want to consider putting in your drawing template if you want it to, and you're tired of every time you start a new drawing, have to stop and run that command all the time. So you put that in your drawing template so it inherits that when you start things up. Now, um, a way of telling whether something is stored with the drawing or with the system, there's a couple of ways of doing that. In the IntelliCAD version, if I go to my settings menu and I look at my IntelliCAD settings and go to the pull right down here where it says System Variable Editor, I'm going to get up this little variable editor, and I'm going to look at, let's say, the AutoCAD Lisp ASDOC, don't even know what it is. It's load the acad.lisp file. If it's set to 0, it just loads the drawing. If it's set to 1, it loads every drawing that's opened. So all of these, it explains as to what those variables mean. Let's go down here and find that view res that we were just talking about. So view res, which is right. Of course, I don't see it. View center, direction, mode, size. Then viz retain. That's great. The one I want to show, they decide not to show us here. Anyway, all right, so here's a zoom factor, for instance. It is an integer value, and it says that it accepts an integer between 3 and 100, and the higher the number, the more the incremental change applied by each mouse wheel forward and backward movement. So that's how much it zooms in and out when you roll the wheel of the mouse. So that's something that's sort of, something you would never really necessarily change. But it tells me up here where it says stored, it's either not stored or it's stored in the drawing or it's stored in the registry. That means it's in the system itself. It is read and write, meaning I can change it, or if it's just read only, it's just telling you what it is. You got all these other little buttons over here to reports, et cetera, change and restore. So that's one way of doing it is with that system variable editor. Um, I'm not exactly sure what yours says, Gretchen. Do you have that same command under settings? Do you have a system variable editor?
I do, and the dialog box looked almost identical.
Okay, so it tells you where it's stored in that regard. All right, so there's another place where it's also stored or also indicated graphically is pretty nice. And I didn't know this until just a couple of years ago. Somebody pointed it out in one of my classes, and I said, oh, I didn't realize that. And that is when you look at your options, in your case, if you go out to the drawing with nothing selected, right click and go down the bottom and choose options. Um, those of us on IntelliCAD, if you go to the settings menu, IntelliCAD settings, and if you look at the IntelliCAD drawing settings, for instance, let's see those here. May not, let me think. If I type options, Gretchen, you may not be able to right click. If you're still running the drawing inspector, when you right click, you need to, I'll show you how to fix that in a second.
I went back in and turned it off.
Oh, okay. Yeah, that's one way to do it is to turn those off. Or you can, while you're running it, you can just say, exit the menu and then run it. Well, I bring that up as a dialogue instead. But it's still going to have that. Yeah, I guess you're going to have to turn it off. All right, so we'll go ahead and right click that and turn it off. Notice now my cursor went away. Now I've got control back to here. Um, yeah, so I don't see the similar thing that I'm talking about, but if I'm in the AutoCAD version, Let me pop that open here real quick. I'll just use one of these little small, simple files. Just something to have open up here. And so here's the other indicator. Come on, hurry up. Wait till this gets up and running. Hmm. Um, so you did have this one, AutoCAD settings system variable editor. So you had this, yeah. So it would tell you not stored in drawing in registry. Now, did they put VRES in here to you? Interesting. Why they don't show you that? Oh well. But here's another place where you could do it is if you're running the options. Notice when this comes up, you're going to have, in particularly, you got a chance of setting certain uh, settings and switches and such that you're looking at files, display, etc. But here's something I never noticed. Right up here in this top line, it tells you that, first of all, what is your current profile, and it tells you um, uh, this little icon is something that's stored in this current drawing. I don't know, this design center line. I don't know what that part's indicating. If anything, I think that's sort of design center line. It could be well, I'm not sure what that indicates. But anyway, this little icon, if you see down here after a particular setting, if you see that icon, that tells you it stores in the current drawing. If you don't see it, it is either not stored or it's stored in the system. So if I look under display, there's that display resolution, arc and circle smoothness. That was that number. We had the viz res or the view res, and it can go 1 to 20,000. So in this particular drawing, it's 20,000. Notice it has these little icons next to it, but say pan and zoom and draw true silhouettes, they do not. So those I don't have to worry about settings. But if I see these little icons next to something that I'm constantly having to come over here and set when I start a new drawing and I'm tired of doing it, like allow long symbol names. Well, that stores with a drawing. I don't really know what that is, anything I've never used. But if it is something that you use and you want it to stay all the time, and you see this little icon next to it, that tells you you need to set it in the drawing template. So then when you make a new drawing using that template, it's going to have that value. Now, that does nothing for drawings that you get in from outside your control. It comes in from a sub-consultant or whatever. That's still going to always be something you're going to need to check and look at. It's just a means of, uh, helping you figure out, some things about the drawing and a little bit of way to control how it's going to work. Now, continuing this business of editing or inquiring and finding things out, that inquiry menu is it's some pretty powerful tools on there. There are things like, there's say a calculator, if you may not have seen it. And it's got standard calculator, it's got scientific, and it's got this conversion. So you can go from feet to meters, international feet, US feet, um, degrees, minutes, seconds to decimal degrees, radians and gons, which, anyway. So it's got a couple of little items there, and there's a little things about it. Like if you say, say 125 feet, I just put the number in, I hit tab. Well, that's going to tell me, well, that's equivalent to 38.1001 meters, and it's equivalent to 125.0003 international feet. Okay. Remember we talked yesterday about that being a slightly different number. Well, you can do things like cut, copy, and paste, and you can now copy that and come down to the command line if you need a result of a number and put that in that result. Obviously, it's not necessarily something that we keep handy. We sort of forget that they're here. Um, I'm guilty of that myself. I still have a calculator somewhere, but I've got a calculator on my phone that pops up an HP 41CV um, application. So that turns my phone into my trusty old HP 41. Um, so I pop that up all the time myself. But so we have a couple of different tools and things there. You've got all of this reporting. You've got a layer report that was much like the layer inspector. So I can say, look at the entire drawing, and it's going to pop up this, different things that I might want. Let's look at everything about the layer. Um, and those are basically the same thing you can get when you pop open the layers dialog. You can see what color, what line type, line weight, and also get an entity count, that sort of thing. So, for whatever good that may or may not do, you may never look at it. Same thing with a style report. You can get any defined text styles, block data. You've got one command down here that says display the last report. So if you've set something up and run a report and then dismissed it and you go, oh, I needed to see what that was, you can come back to it if you say do a listing of your points, list points. It's a very common report that we do. Um, we'll say, okay, now here's that report. Now I close it off and go, oh crap, what was it? Well, I can either run the command again, or I can come back and say, just, display me the last report. So it knows where it was and what it was, and it shows me those numbers, or it shows me that report. And see, at this point, if I decide, well, I'm going to then save that off to a different text file so that I don't have to keep doing it, or even from this report viewer, I might say, let's choose this output to screen. And I'll take my defaults and I'll click over here, set the rotation. And now when I exit the viewer, there's everything that was in that report view sitting over here as an M-text entity, for instance. So this is a nice way of, say, giving a list of coordinates. And let's go to a different font here. I'm going to use a monospace font so the columns would line up, but I'm going to get off that ugly looking text. So I'm just going to use this Courier New, except I guess I have to select everything. And now I can switch it to Courier. Yeah, so now my columns would line up as long as I've so I would have to do that for all of these different ones or shorten these, that kind of stuff. It's just a bunch of text, and that's something I can get out of the report and have it handy if I want to refer to it later. So a couple of really useful things under that inquiry menu. All right, so now let's load up, let's see, let's take a look at some of these other view items. Like if I need to say, I want to look at just my buildings, and I want to isolate those particular buildings. On my view menu, I'm going to choose to isolate layers. Well, I'll select any one item that is representative of that layer. And I can do more than just that layer. Maybe I get a building and a driveway. Or you can get, you can go over here and select more than the buildings and the driveways. You can have multiple ones. It doesn't hurt anything. So I'm going to hit OK. And now it's going to limit what I see and can select and work with to just those things. And if I look and see behind the scenes, I'm going to load up my layers command. You see all of these layers that are not selected there have been frozen. So it has temporarily taken care of that for me. I don't have to worry about what was frozen and not frozen before. And then when I come back to view restore layers, it just puts it back to the way it was before I did the isolate. Okay. So that's isolate layers. Um, if I see that, and if I isolate just the building, keep your eye down here on that trench. So if I'm going to isolate the building, I see that that disappears on me. Okay, and then I'll, restore that and it comes back. So that might be another way for me to say, oh, I really need to put that on my layer buildings instead, even though it's the same color, that sort of fooled me. So that lets me keep track of it. A couple of other things you can do with all these layer controls. You can freeze by pick or freeze by selection. When you freeze by pick, it asks you to pick an entity on a layer to be frozen. And as soon as you click on something, it immediately freezes. So I did that one. Now you've got U to undo, enter to end. So I'm going to undo that one. Let's say if I want to freeze the contours, well, as soon as I click on one of the contours, it freezes that layer. I'll do the contour text. And let's do the, maybe the center lines. Okay. So as soon as you click, it's going to immediately freeze that layer. And now there's no restore button from that. You'd have to, just turn back thaw or on all layers or undo um, undo the action or whatever that you've done. You can also do freeze by select, not by pick, where it asks you so I'm going to pick the contour. It shows me a contour. I'll pick the contour text and maybe these, all the lot line or lot numbers. And then when you hit enter after you're through selecting is when it freezes those. So that's subtle little difference. Freeze by pick, it's immediately as soon as you click it, it freezes the layer. And then you can bring it back to where it was. Let's see one thing. I don't think. All right, so that was my freeze by pick. I wondered if this restore, I don't think restoring does that from that. I think restore only recovers from an isolate. So isolate goes with restore. Yeah, so I just ran that and it says nothing to restore, run isolate layers first. All right, so but that's the way that command works. Then you have to come back and bring this on. Now, one other quick thing to show you about object isolation is, let's say I've got a bunch of things here. I've got all these buildings and driveways, but maybe I only want to work on, say, uh, this driveway, this driveway, and this driveway, but I don't want to have this driveway showing in my way or any of this other stuff. And let's say maybe this house and this house and this house. Those are the ones I want to work on. I want everything else to freeze. Well, if I freeze something in between there, I'm going to be freezing all of the buildings. I can't just do it as freeze the layer. And this is going to be called object isolation. Okay. In AutoCAD, we have, I don't think we have it as a pull right menu here. We don't. But in AutoCAD, you have in the AutoCAD version, you take, instead of, let's say, if you wanted to say isolate that layer, um, you would run that command that we just did before off the view menu to isolate layers, and you would choose that. If you want to isolate only specific things, you would choose the things that you want. So maybe I'll take that particular piece of text, that text, and let's keep the center line. And then I would choose, right click my menu, and I would choose isolate. And I could isolate the object or I could hide just those objects. So if I isolate those, everything else goes away and only the things that I chose to isolate show up. Right click again, isolate, and end the object isolation. That's also down here on my status bar. There's a button down here that says isolate object. So I could do that same thing. Conversely, you can hide the things that you've selected, which is the opposite of isolate. Okay. So in the IntelliCAD version, if I want to do that, and I don't think I've got, yeah, I sure do. I've got the same, I've got the button down here as well. So if I select those and I choose that button, if I say isolate those entities, then it's going to do that. And I can then pop that back up and say unisolate those. But that's also available. Now that is at the CAD level. But that's also available at the Carlson level, and they've had this for years, long before the CAD engines had that. And there are these little icons up here. There's your hide by selection, isolate by selection, and then show all, which is also under view because this is a view type of thing. So I'm going to view, and there is a show hide by selection. Now, this case, because it's a Carlson command, a lot of Carlson commands make you run the command first and then select the option, select the items. Most of the CAD commands let you do either one first. You can either select something and then run the command, or you run the command and answer the prompts to select things. Some of these commands, though, because they're so old, in the days before that was what was called noun verb or verb noun selection, everything used to be verb noun. You gave the command first, then you told it what to work on. Now they're sort of interchangeable, but most of the Carlson commands are still verb noun. Just a little foible to be aware of. So that's there. That's another little set of tools that you can use to help you declutter where you're working and work on. Okay. Some other little things if we wanted to look at a little bit more. On our file menu, we have this thing called drawing cleanup. If I run that, it's a pretty good sized little command with all kinds of different options. I've got a set of defaults. If I click that, I've got a clear button. I can decide which of these things I want to do and whether to work on the entire drawing or on a selection set. Now, there's a couple of ones to point out here. If you do this, and a lot of people run this command as the very first command they do when they get a drawing in from somebody else. They'll just run this command. They'll turn on a lot of these options. But some of the things it might do is it or gives you the option to do. You can get rid of empty layers. You can remove any empty blocks that aren't being used. You can remove any duplicate points, and that means CAD points, not Carlson points. Any duplicate text, any lines that are like contour lines might get exploded into little line segments. They look like they're continuous, but they're not necessarily. So you can say, hey, join those up if they have the same endpoints. You can convert these other entities into polylines to make them easier for the Carlson commands to work with, et cetera, et cetera. Erasing any blank text entities. That's, text that is basically spaces. You got remove duplicates somewhere, convert architectural inches. There's your duplicate line work, and you can give it a tolerance value, so it could be almost duplicate. Okay. You can remove arcs. We did that a little bit yesterday. You've got some reduce the number of vertices in a particular polyline. So take out ones if there's way too many vertices, you can say thin those out. So all of these are different commands that you can run from other places, but it's all done here in this drawing cleanup. Okay. Now I'm going to still hit clear and I'm going to show you what I do with this more than anything else. Is I run this command and I clear everything, but one of the things I want to do is right here. I want to set the elevations for things that are outside a given range to 0 because that blows up so many times where we try to build a surface and we're looking at it top down and we can't see the fact that something might be sitting at negative 25,000 elevation or sitting up at 45,000 and it's way out of whack, and so it would really blow up our surface modeling. We don't see it. But one of the things this is going to do is if I turn this on, then whatever numbers are in these fields down here is the minimum and the maximum. If it's below that or above that, it's going to make it 0. It won't erase it, but it sets it to 0. And then I can look at that later. But before I do that and hit the OK button, and before I just type in some arbitrary numbers, I've got this scan drawing button, and I'm going to click that. And when you click that, it's going to say, okay, I see in your drawing, you've got a minimum elevation. Now, it doesn't report 0, but if it was like just below or just barely above 0, it would report that. So 101 is my lowest, and my maximum is 847. Well, that right there automatically throws up a flag to me. I see, well, I've got something that's 101, but everything else is like around the 840s. I know my site, I look at the contours. I go from like 838 up to 847 or something like that in the upper end. And so if I see an elevation of 101, I'd say, oh, there's something that doesn't fit. Well, I can decide right here if I want to do that. All I have to do is say bump this number up to say, 750 instead of 100, and then it's going to find that and set that to 0 when I hit the OK button. Or I can only, I can just do the scan and just get that and then go out and try to find something there to make sure that I'm changing what I'm needing to change. Okay. So that's the big thing that I use that for, is that one. There's another way that I often do this as well, is I go over to my view control. Instead of looking straight down on the top, I'm going to hit one of these little things that are pointing inward. So I'm doing like a front view. I see, well, there's all the contours. That's where the site elevation is. I see my buildings are set, the contour elevation. Then I look down here and here's the bulk of everything is down at 0. Well, there's that one thing. And I see that the polyline, it has that elevation of 101. At that point, I can choose to put it wherever it happens to be. I can even leave it selected and come back here and hit the top view. I think no, it's not still selected. But if I do something like this, um, I see, well, there's the stray thing. I'm not sure what that is because I can't see what it is in this view. I may come over here and make it a particular color. Let's make it cyan. And let's give it a line weight of something really heavy so I can see it. Well, it didn't change here. Remember what happens when you can't see those views? Look down here in the status bar. Make sure you are displaying your line weights. So there it is. Okay. So now when I go back into my top-down view, I say, okay, so there's that. I can select that again and then set the color back to being by layer. The line weight could be by layer. And then I can decide at that point to change that elevation, make it 0 or do whatever I want. By any means, I can select it and just come up here and say, all right, that's a 0 elevation. Okay. So that's one of the options that's really handy. We always forget about that command, but it's really nice to have it there. A lot of these other commands are going to, let's look at some of these edit commands real quick. But let's open up a little more complicated drawing than this one. I'm not going to save these changes. I'm going to uh, just close that drawing by clicking the X. I'm going to come back to my start page. I'm going to choose to open a file. I'm going to make sure I'm looking at my folder. So that was in where I placed this folder was in Carlson Projects. I had this class and my data sets. So I'm going to look here and I'm going to load this file called sample from T3 Global. And I'm going to choose open. And you're going to see a file that came in from somebody else. In fact, it came in from a company that does aerial mapping. They're here just south of Pittsburgh in an area or in a town called Bridgeville. It's right on I-79 heading down toward Morgantown. And so they do this aerial mapping. And this was actually, and for those of you, at least you Ohio folks are probably familiar with Breezewood on the Pennsylvania Turnpike. It's sort of a big truckers mecca about not quite halfway across the state, but it's east of Pittsburgh, between Pittsburgh and Harrisburg, and it's sort of where it's a busy interchange. Anyway, this was done for the Turnpike Commission, and I see this file, and there's a lot of information here. Again, one of the first things I might do is look at those layers with my drawing inspector. But right now I can, I'm familiar enough with the drawing. So what I want you to do is um, we're going to freeze. We want to freeze this layer of these white looking lines. Those are what are called break lines. If I select that layer, it's on a layer name called VTopo BKLN or break line, right? But they're there, and the aerial mapping company delivered those to let you, when you receive this file, be able to verify that they created the contours that they're giving you from those break lines and from these points. And there's a lot of points down here that we don't see um, because of that little uh, point display style. So if I change those points from just that little dot, let's make these into X's. Now you can see the points a little better. Those
What was that second part? I'm sorry, can you just run that command?
for the points, you mean?
Yes, please.
Yeah, that was under settings. And you should see in our case, on the IntelliCAD side, it's this point style. The actual typed command, if you look down there on the status bar, it says DDP type. That is DDP means you're going to run it as a dialog box. So DDP, and then the type, it's a point type DD display type. So it's a point display style, and it's part of your settings in your AutoCAD version, whether it's going to be in the same, yeah, right here. So AutoCAD settings, point style, and that's where you're going to get this similar box. Okay, so you can choose. In our case, I set mine to this X. You can be any case like that. Okay, so now I don't need to see that, but you can see what's happening is here. As I can see, there's a lot of CAD entity points here. I don't have Carlson points; they're just CAD points, and those were the ones that were used. Now I'm going to go ahead and set that point display style back. I just wanted you to see that they are there. I always get that menu keeps slipping. So if I go back to my point style, I'm going to set that back to the default of that little dot. And so it's not going to take up so much space on the screen. But anyway, those dots and these white lines were what they used to have the computer figure out where the contours go. All right. So for what we're going to do next, I want you to freeze, excuse me, that layer that those white lines are on. And if you remember, that's under view. And you're going to freeze a layer either by pick or by selection. So if I say by pick, I'm going to come up here on the upper left-hand corner in this little curve, and I'm just going to click there once and then hit enter to finish the command. And this would be what would normally be delivered as a finished drawing. And I can see I've got things like um, contours with the elevation labels, and I might verify that I'm sitting at the right elevation. So there's my 1310, I see its elevation, or I go to my drawing inspector and I just want to look at the um, elevation. For instance, well, let's look at the layer name as well. So I'm going to turn that on and the elevation's on. So I'm going to say, there's V topo major, elevation 1310. There's V topo minor, 1311, 12. So I get a sense of, what and I'm going to go ahead and exit that inspector, but I can get a sense of, the same thing that we looked at before. But now, what do I do? Remember that elevation things where we had one that was bad, but we weren't aware of it? Remember where that was? Was in my drawing cleanup on the file menu. And I just hit clear, and then I turn on this set elevation outside range, and I say scan the drawing. And it looks at that drawing, and with the exception of everything that's set specifically at 0, it says you go from 1279 to 1347. Being familiar with the site, I look at that and I say, well, okay, everything looks pretty good in that regard. So you might still have something at the wrong elevation, but it's not grotesquely at the wrong elevation and nothing stands out. All right. So, you've got these broken contours are in these areas that say obscured. The solid contours are where things, and if you notice, the obscured contours are under the tree line. So that's where they couldn't see the ground as clearly. So it all makes sense. And this is a very typical way of the way things are delivered to us. I see things like this that's on a layer called V road curb. It has an elevation of 0. So all of these things are compiled and delivered at 0, but those white things that we turned off were the ones that were actually sitting as 3D polylines in the right vertical space for them to be able to generate this as a surface model. Okay. So what we have here is a larger drawing, a bunch of things, and let's look at a couple of tools that we can do with our drawings in general. If you draw any kind of a shape, let's go to the draw menu and choose 2D polyline. You can just use the current properties, hit OK. And somewhere within our drawing, I'm just going to click, 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 and I'm sort of drawing an arbitrary shape like here and come back up. And then I'm going to say C to close. Boom, there it is. I will even turn on my line weights so you can see them. I'm going to select that and let's make it a little more visible. There we go. So I've got something like that. It can have arcs in it. It can be star shaped. It can be whatever. But one of the things that you sometimes may or may not want to do is to erase everything that's within that or that's without that shape. You might want to trim off your drawing if you don't need the stuff on the outside, but this is where you want to capture everything. And you don't want to go through and try to have to do a trim and a break and all that kind of stuff. So under my edit menu, under edit erase, I have this erase by closed polyline. So if I run that command, it wants me to select the perimeter polyline. So there's that shape I just drew, and it has to be closed. And I can say, all right, using that and deciding that I'm going to use that to get rid of some data, what type of data do I want to consider? Well, you could say, well, I only want to get rid of you know, the text, or I only want to get rid of text and polylines and different things. So I'll leave them all on, but you also see that I have the options to erase on the inside or erase on the outside. So if I were trimming this down and only needed to keep this, I would say erase outside. I would say, okay, and it's going to go about and do its thing. Bada bing, bada boom. There it is. So it found things that were outside, and if they were completely outside, it got rid of them. If like line work, it used this as a trim boundary, but instead of me having to go, trim, select the boundary, and then trim the items, and have to go click, 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 click 100 million times, it takes care of all that for you. Now, a couple things that it doesn't do is it doesn't break text in the middle of something like that. The way it decides on text is if there's a piece of text, it looks at the insertion point of the text. So that text has an insertion point here, this little blue dot that tells me its justification. If I look over on its property, it's left justified. And the insertion point was on the side of this line that we told it to keep. If it was over on this side, maybe it was right justified, the insertion point would be here and part of the text would still be on the inside, then it would look at where that insertion point is and decide to throw it away. And it takes it, the entire piece of text. So it doesn't split text and it doesn't split some blocks. Okay. So I'll undo that back to where we had it before. I'm going to run this command again. I'll select it and then we'll do the difference. We'll erase it on the inside. So we'll say, okay, and there it goes. There's a case where now this piece of text has an insertion point outside, so it kept it. But you see it very nicely cut a little hole in the middle. All right. Now, there's a similar command to that on the edit menu, and it's under break by crossing polyline, as opposed to erase by closed polyline. There's also an erase outside, and that just prompts you to pick the lower, pick diagonal corners. You don't have to pre-draw the shape. And then it takes everything that's outside of it and gets rid of it, even if part of it goes on the inside. So it's a little bit more radical. Temporary erase, I'm going to suggest that you don't ever run that, because if you forget to turn it back, if you forget to run it again, that brings everything back after a temporary, you can't get back to it. If you forget about it, you save the drawing, you come back, well, they're sort of gone. So I wouldn't worry about that command. It's one that they, I don't know why they put it in there. Some customer thought it'd be a good idea, so they decided to help them out. Here's another command, and it's been part of AutoCAD since the very first day they've had AutoCAD, way back in the 80s. A lot of people aren't aware of it. I'm going to show you this one is, if you zoom in on the right-hand side, or left-hand side rather, and let's do a crossing windows selection. I'm going to select, say, this patch of contour lines. And I'm going to just delete those. I'm going to either hit the delete key or run the erase command. Okay. So I've done some things there. Now I'm going to go over here to my draw menu, and I'm going to draw, say, a circle. And I'll do a couple of circles here. And then maybe I would select the smaller circle, right click and copy, and maybe put a couple of things around. And I say, oh, man, you know what? I didn't mean to erase those contour lines. How do I get back to it? Well, you can obviously undo, but you say, yeah, but I need those circles to be where I put them. I don't want to have to undo those. So there's a special command on the edit menu, and it is just a CAD command. It's in both of these systems, and it's called oops. And it's been part of this system since day one. And what oops does is it goes back and finds the most recently erased items and it recovers them, brings them back. So whether it's one or several items that you erase, and it only does it for that one time. So if I had selected these and deleted them, drew a bunch of circles, and then came over here and say selected this line and deleted it, if I oops now, the only oops it's going to do is put back that blue, and it takes the last one that it found as a deletion and brings it back. So in this case, I'm going to undo to get those back. Okay, so that's a command that's useful if you need to keep intervening commands, but you still need to go back and undo those erasures. Okay. Now the command of breaking is that I was getting ready to show you next is a nice little command that can help you do certain things. Instead of erasing inside or outside, it's going to break the things that cross a boundary polyline or a crossing polyline. And so instead of erasing it, it breaks it at that edge, and then you can do different things with the different pieces. Here's a prime example of something that might be useful for you. If you've got, say, a design file that has proposed contours and existing contours, and you're sort of wanting to try to work on those things in a separate fashion. That's actually going to be part of our little exercise that we're going to do later on this afternoon. But what you would do is run the command, or let's even do this. Before we run that command, let's isolate some layers. I'm going to choose View, Isolate Layers, and I'm going to zoom in here, and I'm going to pick the boundary polyline that I drew. I'm going to pick examples of these obscured contours. Maybe that stream, and then over here, the main contours as well. All right, so that's all I really want to see. I'm going to hit enter. And so now I'm down to just contours in this boundary. And here's why you might want to be able to run this command that preserves stuff instead of erasing it. So if I go next to edit break, sorry, by crossing polyline, it wants me to select the clip edge polyline. Well, that's this one that I've drawn. And now it says select the polylines and lines that you want to be clipped. So I didn't really need to isolate these. It only works on lines and polylines. But let's just go up here. I'm just going to grab all of it. All right. So it's going to consider all of them, and it's going to use this as a breaking edge. And now it asks if I want to specify the layer name for the inside segments. Well, this can be useful. I'm going to say yes. And it wants to know the layer name for those inside segments. I'm just going to call it inside. Okay. And you want to specify a layer name for the outside segments. Yeah, well, might as well. And we'll call that one outside. Clever as I am. And so what it does then is it goes through here and finds all of those things, and it puts them on those particular layers. Now let's see, what do I have here? I've got, that's a layer outside, that's a layer inside. So yeah, so layer outside and inside have a color because it created them new. The color was white. But you see the things that are still green? Well, those are things that did not cross the boundary, so they weren't touched. Everything else was modified. So if I've got, let's put them, you could go through here and match the same color as these outside, let's say, but If I now wanted to, say, freeze off those, so that had the same effect of erasing the things that are in there, but they are on this layer. I'm gonna go back and freeze these off. So they were on that layer, I mean, that I froze. They went away, but I was able to, bring them back if I needed. So I still have the data. So that's all the stuff on the inside that I trimmed. I can do a similar thing then and freeze the things that are on the outside. So oops, sorry, out here, it would do the outside and yet keep these on the inside, turn those off that crossed it. So sometimes it's nice to be able to simulate that you have taken a cookie cutter and cut out some stuff, and yet you still want to keep the data. So that keeps you from having to spend all the time to go around and click, 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 click. It just uses those tools and commands. Now that's what I wanted us to think about, and we're going to take us our break now. Um, but I want you to start to think along these lines. Start to think, well, I know how to do something, and it takes, several trips, and repetitive action. Maybe there's a faster way of doing it. So start to explore some of these things. If I look at erase, and here's a great command, we'll use it, from time to time in our exercises. It's called erase by layer. And when I choose that, you see it lets me pick layers from the screen or from a list of layer names, or I can just type them and I can take everything or restrict it to certain things that I select and, run that as a command to clean something up. We've got these other types of things, anything that you might choose. You can extend a line to go up and meet the edge of something. That's just standard CAD extend. But I've got this extend by distance, which is a really handy little tool if I'm trying to um, do something like, let's say, I'm surveying out there in the fields, and I say, all right, I've got a part of a building here, but and then maybe it came, down to this corner, but I couldn't see the other corner, or I couldn't see, the rest of the building. But I got these corners, and I went ahead and got measurements. I couldn't view it, maybe there's a tree in the way or something. So if I run that command to extend by distance, when I choose that, whichever end I choose, it's going to start me from that end. And I get all of these options down here at the bottom. And if I type H for help, that's what all of these things mean. I can extend a particular distance. I can turn left and right and turn specific angles. I can come back and close it off as a figure. So I might have something like this and say, all right, I'm going to go a total distance of 60 feet. So I'm going to type T for total and 60 for 60. So it's going to push it out to be 60 feet. Well, I'm going to turn left, which turns me pointing in the left direction. I'm going to go 25 feet. I'm going to go R 25. So I can combine certain things. I'm going to go left 10 and left again. Let's say 120. No, not quite 120. Let's say it's 60. 85. So 85. And if I type C to close, it's going to go up there and close back to where that was, or I could have known what that distance was and figured it out. Once I'm finished, I just hit enter to finish it. And now I've made that into the shape of some kind of a building outline that maybe I was able to measure with a tape measure. I couldn't get all the surveyed points in, um, but just a real handy little tool. Same thing as if I had, let's undo that. I've got a similar thing on the survey menu called four-sided building. If you choose that, it's going to lock my system up. Okay, let's go over here and draw a 2D polyline. And so now if I did under survey, four-sided building, when you select that, it automatically finishes out as if it were a four-sided building. So maybe you shot the three, excuse me, the three building corners, you didn't get the back corner, and it would finish that out. There's a similar command, or actually it's the same command, but if you did something like this, I'm going to go to my command, edit polyline utilities, remove polyline segment. There's that icon. So I'm going to choose it up actually up here from this toolbar. So I'm going to remove that segment, and that segment. So now I've only got the one. And if I run that command again, survey four-sided building, if it only has one segment, it doesn't know which side I want to go, and it doesn't know how far. So down here, it's asking me, well, what's that offset? Well, let's make it say 25 feet. And now which side? Let's go over here. So it now draws it over there as a four-sided building. So that's something similar, but in the case of this one, it's finally coming around to that. So in the case of the one that we just did before, that had those different offsets and L's and things that were not rectangular, I can't use that command. This is actually for only four-sided buildings, but all of those are things that are going to help you. So I want you to get into sort of exploration mode as you go through some of these things. Standard offset, anytime you see the word standard, that typically means that's your normal CAD tool. But you have things where you can offset to a particular layer. You can offset to whatever distance it is that leaves you with a required amount of area that you've enclosed. You can do multiple offsets. You can, all of these different things. We don't have time to go through every command, but you can see when you're trying to do something, um, some things that might really be helpful. To line, say, one set of data up with another part of your drawing, this align command, 2D or standard align, is just beautiful. It basically says, take all these things and they're over here in this arbitrary space, but I've got some good survey data over here and I want to put this in the right spot. So it's going to ask you for a starting point and an ending point for two different points. And it's going to say all of the things you want to move. And say start from this point, go to that point as your first point. And then it's got a second point, source and destination. And then it offers to move everything, rotate it, scale it, do what we in surveyors, would typically call that as a transformation, a coordinate transformation. And it does it very quickly and neatly. A lot of these things are the same or just standard CAD tools, but there's a lot of stuff down here. There's a lot of things like under change, elevation, style, colors, and you got these polyline commands. There's a wealth of information here, and 3D utilities, the same thing. Even under here, image. So there's some things that are sort of hidden. Here's one of my favorites on the draw commands, the draw menus. There's a lot of these that we're going to still be using, but if I look at an arc, notice that it's the way the options are there. You see terms like PC, center or radius, and PT, so the pointed curve, the pointed tangent, very engineering type of things and surveyor type of things. Um, so that it puts it in terms that we understand from our industry as opposed to being a graphic artist or a mathematician. But here's the command down here that we don't, that it's easy to overlook. You can do a best fit curve, which draws an arc between two endpoints with a given radius that is created from sampling points in between. So if you got a bunch of points scattered through an area that are supposed to define an arc, And if you were to just play connect the dots, it wouldn't necessarily be truly part of a circular arc. Well, this actually does a least squares best fit through that data. There's also this one, a curve calculator. It's very easy to overlook. It brings up this little dockable, floatable calculator. And let's say I wanted a curve of, say, 50 feet. And let's say I wanted it to be 100 feet long. So as long as I've got enough information to calculate the rest of it, it figures out what this is. I can then say plot it, start it right here, direction of the chord. Let's say we'll go direction input, say enter of quadrant qdd.mmss. That means go to which quadrant, 1, 2, 3, or 4. Let's just make it 90 degrees east. So that's quadrant 1 of 90 degrees. No decimals, minutes, and seconds needed. And so it took that 50-foot radius arc of 100 feet of length, and where I clicked it, and it set the chord direction based on what I typed into that. So there's all of that's done from this calculator. I've also got, if I clear that out, I can select, or I can choose 3 points. So let's figure out, let's see, is this arc in the correct direction? Let's say no, so it's going to, I cleared it all out. So anyway, so if I did 3 points, so if I went from, say, the corner of that building and a point on the arc, let's say right in here somewhere, and I go to this other endpoint as the endpoint. So it went from there, went through the point in the middle, and it ended at that point. It measured and told me what that arc is. I can again plot that, and it says plot the last 3-point arc. Sure. So there it is. So if I start there and I go through that point and I end there, that's the arc that defined by those 3 points. Okay. You can, let's take this as an arc. I'm going to move it up here, and let's change its radius a little bit, maybe change its shape and its length. So now there is an existing arc, or even an arc portion of a polyline. If I say, instead of 3 points, let's just say I select, and if I select this arc, it reads all the data and shows it for me. So it's a really nice tool, but it's really hidden kind of deep. So, get yourself familiar with these, and, try to find ways to make life easier is what I'm getting at. Okay. You can generate a report, save the data. That's about it. Oh, you also have whether or not you're using roadway or railroad definitions for your degree of curve and arc length. So, pretty good standard little tools, and that's on the draw arc way down here, curve calc kind of tools. So there's a lot of stuff, a lot of things that are hidden away. So sort of explore those when you get a chance. We're going to hit them as we go through our exercises from this point forward. So at this point, I appreciate everybody's patience, but I will finally get you to your nice mid-morning break. So we'll see you back here at 11:15. Any questions? I'll be glad to stick around and answer those, or we can answer them when you come back. We're not going to save this file. If you have, you'll need to download this file again, because we're going to use it for some exercise stuff later. So don't save any changes to it. Just go ahead and close it, and we'll put that back into this, no file, no file zone, if you want to call it that. All right. So I'll see everybody here at 11:15. First of all, anybody have any questions? Go ahead and ask them now.
I just have one question about that 2D to 3D.
Uh-huh.
And it was in that, yeah, if that's in AutoCAD, Would you just remember how we copied that one contour line and then you put it down at the bottom right and then you changed it so that it's it became a 3D line,
Right.
and then the middle grips were they went away.
Right.
Anyway, I don't know. I've tried several of those and I haven't been able to get that to work. That was the only thing I had a
Oh,
question on.
um,
So,
well, sure, sure. I'll show you. Let me open that same file that we had here before here.
okay.
It was the civil demo, I guess. Um, oh, good heavens. Let me see. Where am I? Here drive. See, Carlson projects and civil demo. And so let's open that up. And let's take
Wow.
this guy. And now we're going to copy um, that over down to here. Don't have to copy it. We could have left it in place and changed that one as well. So there it is. And I can see that because I've got those midpoint grips, that's a 2D. I need to make that a 3D, right? So with me so far?
Yes, and I'm right there.
Okay. So what we need to do is we're in the civil module, so we have access to that 3D data. We're going to say 2D to 3D polyline, and you have to tell it how you want to create that as a 3D polyline. And you can either do, without changing the elevations, you could come down here and say, I want to turn a lightweight or a 2D polyline into a 3D polyline. If you do that, it's going to do that, but it's going to set all of the vertices at that same flat elevation, but it will still be a 3D polyline in terms of its entity. What I did for that one to give it changing elevation, I said use it by start and end elevation. Okay, so what is it that you're doing when you're choosing 2D to 3D? Are you choosing a method?
I yeah, I mean, I missed that particular choice, so I was just starting at the top and just kind of I tried all of them, and I wasn't really sure which one you ended
Well,
up with.
yeah.
So by
Well,
start to end,
yeah.
so I've done that, and it says enter starting elevation 844.
Okay.
So I'll just hit enter,
All right.
get back over here, and then ending elevation, at the end of that line.
Right. So it's reading what that line is and offering you those numbers. You don't have to use them. And I typed in 800 to 850.
Oh, okay. That's what I did. Okay, so I just missed you assigning that elevation
No
because
worries.
everything I did kept giving me the same elevation. I'm like, okay, I've
Ah,
done something
okay,
wrong.
so yeah, if you just took the default, that's all it's doing is it's reading it and offering that to you to use if you want. And that has the same effect as this LW polyline to 3D polyline. If I choose that,
Right.
I now see that it is indeed a 3D polyline, but each of these vertices, keep your eye on this vertex Z, it's 843. I go to the next one, it's 843, 843, 843. This number down here never changes because all I did was change it into a 3D polyline. Now, also on that menu is I have this polyline elevation editor, and that's a really powerful tool. So if I select that, I get this little, let me get rid of this. I get this thing here where I can look at these individual vertices. I can change the elevation, or I can go from here up to here, number 5. I'm going to lock that. I'm going to lock number 1 and go to number 5. But to go from here to here, I want to make my slope at, let's say, -2.5%. So I'll say -2.5. So it starts at 8. Actually, I need to uncheck that. Let me see here. Now, from here, slope, slope in, actually, let me set that at -2.5%. So it starts at 843 and it comes down here to 2.5%, and then it locks that portion at that stage. And then maybe from there, I go down to Here and at this elevation, now I'm going to come in instead of negative 2.5, maybe I'm coming in at a positive 5%. So it came down
Mm-hmm.
843 down to here, so 2.5 to 5%. Then it goes flat back, and I'm going to come out to the final end of it and say, um, instead of flat, I'm just going to change that to 8, instead of 857, let's make that 860 as an elevation. Okay, so now, and you get a little
Mm-hmm.
preview of what it looks like. So it changes.
Mm-hmm.
It's varying slope, whereas before I went from one elevation to another elevation and it was a constant slope. So
I
now,
see.
once I'm done with that and I choose OK, it's just a nice little way of setting that up. And if I look at my uh, drawing inspector, and let's look at the polyline data. So in here in this segment, you see it's got a slope of negative 2.5, and you get up past the fifth one, and now there's that 5% slope, and it's going to at some point get to that closing slope. There it is, 1%. Okay. So it is indeed variable. It's also, I can view it in 3D. Let me see. Probably easiest to go into the viewer itself. And let's give it an
Carlson
exaggerated
software
scale.
3D viewer.
So there you can see
And
it's actually changing slope as it goes through it's not, so it looks like a bent paper clip. Okay. And,
okay.
and we're going to go through all that, how to use that viewer and all that. That's going to be part of what we
Okay,
do.
that's pretty cool. Yeah.
Yeah. It's a hugely, hugely helpful tool, um, especially as we're evaluating things. Because I can do this, I can do it out here in the CAD world to sort of get a qualitative view of it, or I can look at it in this specialized tool with Carlson, and I get a whole lot more tools. I can do things like ignore zero elevation items or not. I can choose to, let me turn this exaggerated scale back down. And then if I look at this, I see these are just the elevated items. Let's come back into my plan view and say, don't ignore zero. Um, Now, the reason it doesn't line up exactly is because there's a forced perspective going on here that you can see with this box here. You see, so it shows you what's down at zero, what's there. I can even say box with
Hmm.
label. You can see, the distance and elevation. You can look at things by color by elevation. So here it goes from the blue areas through the green areas to the red areas. Um, Ignore zeros again, and now you see it's a little bit flatter, but it does vary. So there's a lot of stuff that I can figure out and find out about my drawings that this viewer helps me that I just don't have any other tool. And it's so quick to load the data, look at it, and figure out whether you're doing something correctly or not. Okay.
Okay. And then this is probably a very odd question, but I noticed that. So I use I don't use a wheel mouse. I mean, I do. It's a wheel and a ball mouse.
Sure. Yeah.
And so you have been able to essentially, I guess, use that upper right, um, the north south, the little viewer or something, right? So how do you do that without, in my case, I have to sort of manually push those buttons around, and I'm just trying to drag it, and it doesn't work.
Well,
Like,
you can't drag this picture. This tool is always going to be sitting up there. You can't do anything with it. If you're
uh,
if you're trying to do this, with the mouse.
yes, and it may just be because I don't have the same type of mouse as most everybody else.
All I'm
So,
doing up there now, you've got these arrow like you can click these once and they'll jump.
Right. Yeah. I'm looking for,
Yeah, if I click on, say, this corner, this edge, that corner, there's certain presets that you can sort of get to.
right.
And
But
then
you're
you
just using your mouse, right, to just sort of manipulate the up and down in order to see the three-dimensional view. Is that correct?
is correct. And I'm doing that with the left mouse button, so it's not really
Yeah.
wheel. Now, if I want to look at that as a particular, uh,
Yeah, I'll keep looking on the internet for that. Again, I just use a I use a the ball mouse, the trackball,
mhm.
and so it doesn't have that same. I need to reprogram it probably in order to get that functionality.
No, I mean, you still, even with the ball mouse, you should be able to come up here and click these with the left
Oh,
mouse.
I can. I meant just
If you're talking about like when you see me do this, is that
yes. Yes.
okay? Well, I yeah, now that when I'm doing that, I'm holding the shift key down and
Oh.
then and using the wheel as a button. So I'm pressing that in. I don't know how you would do that with a
Oh
ball.
my goodness. No, that's all it took. Uh,
Oh, okay. I see what, yeah.
it's well, it's no, I just had it a second ago. Yeah, so
Yeah.
I have to press down for
Press,
me,
yeah.
press down on the actual wheel with the shift, but that's perfect. That
Yeah.
was the only thing I've been missing this whole time, and I know that was so simple, but I mean, I've tried so many different. I never thought to put down the shift. So
So
yeah,
so that's just a little shortcut that I
okay,
use a lot. But again, a lot of people go their whole careers using CAD and never know that trick. And that works in MicroStation as well as AutoCAD. So yeah.
okay.
All right.
Thank you.
You're welcome. Now,
Okay,
you giving up your break when these
that
if Lane and Storm have not gotten, if they have gotten back yet, gentlemen, we're going to actually break till 11:25. I'm going to give you at least 10
oh,
minutes to try to get some emails answered and a cup of coffee,
okay.
or
I'll be right back.
either consumed or not. So I'll see everybody back at 11:25. Okay.
Okay.
Ken, your mic is muted.
Wow. No wonder you guys didn't hear me about when I was asking if you were back yet. Wow. Good gracious. I'm so sorry. Thank you for letting me know that. All right. So, what I was flapping on about is is we talk a lot about points in our um, discussion here, and there's two different things that we're talking about here. We have CAD points, which is a standard CAD entity, just like a line, a polyline, a circle, a piece of text, a point, and they live independently of those other entities, and that you can either have them or don't. But when we talk about in Carlson, we're talking about a point, of this form that has the um, symbol and a point number, an elevation, and a description. And it also includes that CAD point entity as part of that little group of three things. But the reason we have those and use them is so that we can refer to those locations by point number and by a range of point numbers. So we could say 3-5, and it would mean point 3 and 4 and 5. And you can see see right over here, it says, okay, so what good are these points? Because it lets us do things like when you're drawing line work, you can go by, say, 5-13, it will go 5 to 6 to 7, etc., all the way up to number 13. And if you only had 5 through 10 and then you skipped 11 and it went 12 and 13, then it would go 8, 9, 10, 12, 13. So having a gap in there doesn't matter. You're just referring to that as any group in a sort of a loose association. Okay. So I'm going to let you understand that. Now, here's another difference too as well. This question, as we first start talking about points over here, is that, the question is, are there points at these locations, A, B, C, and D? And the answer is no, even though I can define those locations. Those are called the vertices, plural for excuse me, plural for vertex. So they certainly exist and they have X, Y, and Z information about their position, but there is no entity there separate from the polyline itself, or if this is a series of three lines that just share endpoints. I can put points there by snapping to those points, but there's no real intrinsic point sitting there on it. Okay. So you could, like I said, add those points to it. And a lot of times, for instance, Storm, I think you were the one that said you do a lot of field work and you have to do construction stakeout and stuff. Well, that's a prime example of, let's say, those are the corners of a building and you got to stake that building out, or, the parking lot. Well, how do you know what their point is? Well, you'd have to put a point on that thing in the drawing and then say, all right, now I want to go stake out, point 17, 18, 19, and 20, because you've located points on those corners and it now can use those points in all of these coordinate geometry calculations. Okay, so it's just a convenience for us. So we're not really required to have them or to use them. In fact, I've done entire major jobs without using points, but if I have any kind of survey work whatsoever, I typically always have them. So here's our um, little step through exercise, and I'm going to leave you the one, we're going to go through this points exercise, but then we're going to talk about over here, this other section. I'm going to leave this to your own sort of homework and advancement on your own after class, called point groups. And basically all that is just a mechanism that allows us to um, treat points by a name group. You know what? I actually will do a quick exercise through there. It's not that hard to do, but I don't want to get too far behind the curve here. So let's go ahead and open a new file. We're going to create a new file, a new drawing. We choose whatever template you want to choose. It doesn't matter whatsoever. I'm just going to take the default. I'll hit finish. And I'm going to go to my new drawing name in part of my wizard. I'm going to choose the set button. I'm going to make sure I'm pointing to my data set folder where I'm working. And then I'm going to give this one, I'm going to call this one just points example. And let's give it a horizontal scale of, oh, let's say 30. It doesn't matter. And coordinate system, we're going to just say none because it's just arbitrary coordinates. We'll say next. And at this point, okay, now there it says, you see, I get this warning due to a known limitation, unable to set annotation scale for the drawing saved in older format. Down here at the bottom of my command prompt, you can ignore that for our purposes, but there's that's an indication to me that I need to go back and update my drawing templates. They're too old to be able to set that to be automatic. But anyway, that's neither here nor there for what we're doing. Now, at this point, we could just say next and finish and be done with no import. But let's look at what this wizard can also do for us. Because part of our exercise says we're going to open up that coordinate file. But right now it's offering to create a coordinate file with the same name as our drawing file called pointsexample.crd, but that's not the one I want. So I could choose set, making sure up here above it that I say I want to use an existing file, and I'll choose set. And again, I've got these two tabs at the top. Make sure you're on existing. Find this one that's exercise 1 coordinates and say open. Okay. So now I've got it, but I'm not going to do any further imports. So I'm going to leave that setting at none, and I'm going to say next, and off it goes. Now, nothing in my drawing, but what do I have? I look at the top stripe of my the window, the application window up here at the top stripe, and I see I'm running Carlson Survey 2023 with IntelliCAD. I have a CRD file called exercise 1 coordinates, and I have the drawing file called points example.dwg. And to verify what I've gotten at points, I'm going to go to my points menu and I'm going to choose list points. And I'll just hit the all button. So list them all and say, okay. And lo and behold, I've got 1 through 22. I've also got this 101, 2, 3, and 4. Now, where those came from, in case you were curious or hadn't been paying attention, is back in some of our scribble works. When I also had that same file open, I set those points. I think it was when we were doing that little pretend intersection with the arc that came around the parking lot. Remember? And in fact, let me show you some of the things you can do with this point file. If I wanted to see where that was, I could draw locate all these points and zoom to them, or I know that what these points 101 through 104 typically were. I'm going to do something here just to see it. I'm going to say, go to my draw menu with a 2D polyline, and just so you'll be able to see it a little better here, I'm going to make it yellow, and I'm going to say, okay. And it says pick a point or point numbers. Now remember, nothing's in my drawing yet, but because I have a coordinate file associated, I have access to points 101 through 104, or I could even say to 199 or 10,000. So I do that, and it's going to go through starting at 101 and draw it up to 102, 103, 104. And there's nothing else. So it ran out of numbers. So I'll just hit enter to finish. And there that is. Okay, so now when we were doing the work, this was actually, an arc that went through that point, but you get the idea. So I was sort of verifying where those points were. Now, I still don't have those points in the file, but I used the point numbers to create this geometry. All right, I'll go ahead and get rid of that. And you could again, but what we typically do is we go to the points menu and we say draw locate points, because we're running to see where these points are. And then we're going to typically set a particular, whatever symbol of our choice. I'll use that X symbol, erase and redraw, and I'll just say draw them all. And so here they were. Let me turn this. Nation. Put the annotated points off. So now let me draw locate those points again. Draw all. There we go. So now there they are, and there's my 1 through 22, but I also had that 101, 102, 103, and 104. Now, so I don't need those points necessarily anymore, and I might want to get rid of them. And so there's several ways you can do that. You can simply select them in your CAD file and delete them. Now they're gone from my CAD file, but they're still in the coordinate file, as you can see. So if I redraw those points, and I'll just say hit draw all again. So now they're back. So if I want to erase those, I have to do that as a specific erase points command on the points menu. And I've got a, an edit points, which is going to bring up like a spreadsheet here. And I can come down to say 101 to 104. And once they're selected, I can say delete that range, 101 to 104, or I can even, I think if I say delete row, yeah, delete row is one at a time. Let's see if I'm just hitting the delete key on my keyboard, but that's just taking off the numbers. So if I delete a range, 101 through 104. Right, so now it's supposed to have gotten rid of those. Actually, those were, Now, if I delete range 101 through 104. Now, there we go. So then if I save that and exit that, that will take care of it. All right, now I'm not going to do that. I'm going to cancel that and say, don't save the changes. But if we do alternately points, erase points by screen, how do I want to pick them? By screen, by group, or by number? Let's just go by number. And I'm going to say 101 to 104. Now, here's the difference in what before that I did. I just erased them out of the drawing. This is, do I want to delete the points from the coordinate file? Yes or no? So if I say yes, at this stage, it will take them out of the coordinate file, and also out of the drawing. So let's just say no at this point and delete the point symbols. Yes. All right. So it was just like I had drawn a box around them and hit the delete key. They're out of the drawing, but they're not out of the coordinate file. And if I go to my points menu, here's another couple of ways of looking at this. I can go to my points utilities at the bottom, and I can choose to update the drawing from the coordinate file or update the coordinate file from the drawing. That's one thing under these several different utilities. Another nicer way of looking at all those utilities together, though, is up here at the top, is coordinate file utilities, which has that little Swiss Army knife and has a lot of control that you can do. It tells you what your coordinate file is, what your highest point number is. All the buttons on the left have to do with the file itself and different files, whereas the buttons on the right have to do with individual points or groups of point numbers, point ranges, that sort of stuff. You get reports. You can look at point history. So if I say want to edit my points or delete my points, I'm going to there look over here under my points column and say delete points by group, description, or number. I'll say by number 101 to 104. Do I sure I want to delete them? Yes. And so now that takes them out of the coordinate file, whether they're in the drawing or not, doesn't matter. I now look at my list points. I say all, and I say okay, and now you see it goes 1 to 22, and I've now gotten rid of those particular points. I may then also come from here and let's say edit and assign point. So let's do another, let's call it instead of 20, 22, let's go to say 50, 51. And let's put that at say 1,000. Whoops. To 1,000 and an elevation of 100 and a description of test. Say, okay, so that's a way of sort of getting into that just text entry of some points. All right, so now I go back to list my points and I see I've got 1 through 22 and there's point 51 down below. All right. My point history is also down here on the right. If I choose point history, notice it's kept a running list of all the different things I've been doing with my points from a command perspective or from my points perspective. Here's 51 was created by input edit point test or input edit point. The description is test. By commands though, if I can, let's say if I didn't mean to do all that stuff, I want to say, instead of this editing is 51, and instead of deleting these, I'm going to select that and say undo through selected. And it says, well, are you sure you want to undo? Yeah, okay. So now it has to undo all the steps down to that. And now I've got this as one of the commands was a history undo. Okay, so now I've got these points 101, 2, 3, and 4. There they're back. I say close and exit. And there are those points back in my drawing. Now, again, if I take these out, if I update my drawing from my points, and that's going to be on the left-hand side, update the drawing from the coordinate file. And let's just say, okay, and it's going to update 22 points. Did I lose my? Okay, they're there. All right, so now if I update the drawing from the coordinate file, here's, I must not have checked something here. All right, right, there's one of the options. I can draw points from the coordinate file that are not in the drawing. I can also erase points from the drawing that are not in the coordinate file. So that's one way you can do that. So if I say, okay, you're going to now, it updated 22 points and it drew 4 points, and the 4 points it drew were the 101, 2, 3, and 4. Likewise, you can do that in the opposite direction, is if you update the coordinate file from the drawing. And one of the options there is to say, okay, so now select any entities. I'm just going to type the word all to select everything, hit enter, and now we see we list the points. Now what it does, because I didn't have points 101, 2, 3, and 4 in the drawing, it only was able to look at points that are in the drawing, and then it goes back and looks at the coordinate file and it updates them to match the ones that it found in the drawing. because it didn't find 101 through 104, it still leaves them alone in the coordinate file because it didn't find them in the drawing. But when you update the drawing from the coordinate file, then it can take care of those changes, and you have the option to add into the drawing something from the coordinate file that might be missing, or take out of the drawing any points that you have in the drawing that are not in the coordinate file. So it's a way to synchronize those sets of points. Okay. So with that, and if we look at back at this exercise with our points, and we sort of looked at some of this before, we can draw our line work, say, through these series of points. And that's really all this exercise is showing you what to do. All right, but extending that thought, and so we can get to a nice stopping point here to come back after lunch to do our surface modeling. Let's look at this point groups really quickly. And we're going to open that file that we had earlier called civildemo.dwg, and we're going to set the coordinate file to the other one there called exercise 2 point groups. Okay. So in doing that, we're going to go ahead and close this file. No need to save it. Let's open files and let's make sure we're in our data set. And we're going to find this file called Civil Demo, and we're going to open it. So I'm going to open that Civil Demo. And as per the instructions on the exercise, what I have, do I want to open it? And I'm sorry, I've got it open over here. Let me save as Civil Demo. They can't. There we go. So I'm going to open the file, Civil Demo. All right. Now, when it says in our book here, it says open the CAD file, Civil Demo, and set the current coordinate file to exercise 2. So that means, like, unlike the wizard, when you start a new file and it creates the coordinate file the same name, I need to take a specific step and go to points and set the coordinate file, which is right up here in the top part of the commands. So I'm going to set the coordinate file now to this exercise 2 point groups and choose open. Okay. Now, this set of points that are in this coordinate file, they're not in the drawing, but I've got them in this coordinate file. I'm going to look at points, list points. I'll just choose all and say okay. And you see the descriptions that I've got, and I've got some of these things that have no elevations, some that have elevations, like the points on the building description have elevations because they were set based on the house elevations. I've got edge of pavement points. I've got more building points. P-core, that's my property corner. So I've got a couple of different common type of descriptions. EOP edge of pavement, BLDG building, EOP rad PT radius point. That's the radius point of that edge of pavement. Same thing, BDY for boundary. Now, the way those were created, just to let you know, is on the survey or the COGO menu, rather, there's this thing called create points from entities. And when I was setting this file up, I would maybe isolate all of the buildings and say create points from entities. And I just draw a window around all of those buildings, and it goes through every little vertex points of each one of those buildings, and it generates a point and gives it a description called BLDG, and it reads its elevation, and it just creates those, without me having to click, 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 click. So that way, in Storm, you can see I could go to my well, for heaven's sake. But it used to be on the survey menu. Let me see. I'm looking for sheets, but maybe maybe they moved it to coordinate geometry. Oh, yeah, it's there at the bottom called radial stakeout. I was not looking for the word radial. So if I do a radial stakeout, then I can tell it I'm going to be sitting on whatever control points I may have, choose from a list or pick from the screen. And then, what points do I want to choose to compute. So I said my occupied, my back site, maximum distance, the range of points to compute. Here's just 1 through 144. Well, that's not going to let me use my group, but that lets me choose those. I'll go ahead and say okay. And then that tells me to set these points, I'm going to set point number 5. I'm sitting on 1, looking at 2. To set number 5, I'm going to turn this angle right at this angle right, that distance. There's my coordinates, etc. Okay, so that's just a computation for setting those up. I was trying to specifically look for a tool that made it quick and easy to do the computation based on the point groups. But in any case, I could simply make another coordinate file for my stakeout. Let's do that real quick. I don't have any groups, but I could, based on that description, I could have said, take all of the points in this file that have a description of BLDG and send them to another file called, stakeout file or what have you. And that's in your coordinate file utilities. That's where you can do this import, export coordinate points, all of those different types of tools. So just sort of keep track of those different tool sets and what they can do. And here's what you can do now with those groups if you've created groups. And again, I'm going to let you, go through this, the minutia of all of this, but here's sort of a little handy, sneaky trick if you want to use these points. Now I've got some points. Do I have any groups? I'm going to go up to the points menu and choose point group manager. I see there's no groups. I want to get a group of corners. So I'm going to choose down here at the bottom to create. I'm going to give a group name. I'm just going to call it corners. I don't have to give it a description, but I'm going to include not everything. So I'm going to uncheck that, but I'm going to come down here under description and I'm going to say set from list. I'm going to see here, I've got BDY points. So I'm going to choose one of those. I'm not interested in these radius points. I'm just going to get the points along the boundary. And I had some other ones here, one called P-core for property corner. So I'm going to hold the control key down and click one of those. I do not think edge of pavement needs to be done. All right, so I think that's all I need. Yep, that's it. I'll say okay. And so now it's going to say in a group called corners, look for a description of BDY and PCOR. Wildcards are allowed. So if I said BDY asterisk, it would have also included the radius points, but I don't want those. And I'm going to say save. All right, so there we go. I've got corners as a group, and you can see the different points that it pulled out of my overall points list. I could make another group. I'm going to create another group called buildings. And I will say not include all, but just by description. And I can just simply type it if I knew what it was to type BLDG, or let's select set by selection. There's not, I didn't know points to select. So let's select from list rather. There's BLDG and say, okay. And we'll say that. And so now I've got buildings, which are all of these points, and corners are all of those points. Yep, so there it is. I've got a group set of groups that are created. And all that is a quick way of referring to a range of points. So now if I want to list points, or Storm, if I want to go out and stake out points, when I do something like that that's asking me for points and point numbers, I usually have this button here called point group. So instead of looking at that and trying to remember what the points were, if I say point group and I just want to look at the corners, I would say, okay, there it is. And so now I've got boundary and or BDY and P core, but I don't have BLDG and I don't have EOP. I've got all of these specific ones narrowed down based on that group. Okay. And here's the little trick that I was getting ready to show you. I'm going to go to my view layer control, and I'm going to make a layer. Do I see one already? I do not. Let's make a new layer. So I'm going to choose new layer, and I'm going to call that corners. And I'll make that to be yellow, and I'll make it a little bigger. Okay, now, when you draw a point, let's say we draw locate points. I'll go to the point menu, draw locate point. If I choose to draw locate point on whatever layer name down here, and I draw a range, I'm just going to say, 1 to 5. Well, there it's drawn those points 1, 2, 3, 4, 5 by point number, elevation, and description. Okay. But one of the things that I might want to do, if I've computed all those points, I'm going to undo those point draws, is, let me also change my text style. So now instead of drawing all those and then having to freeze the point numbers and the elevations and the descriptions, which, you could, nothing wrong with that, but you can also simply draw those points without turning those other things on. So let's go to the points menu and say draw locate points. I'm going to set this symbol to be, instead of points, I'm going to pull this down and choose points plus wipeout. And I'm going to use this circle. So it's going to hide what's underneath the circle. And I'm going to choose down here at the bottom layer name, I'm going to choose select, and I'm going to choose corners. So it's going to go on that layer. And up here now in these check boxes, I'm going to uncheck descriptions, elevations, and point numbers. Okay. Now, could you do this with a wildcard description match? Certainly you could at this point say PCOR asterisk and then do it again for BDY. Or because we took the effort to make a group, I'm going to draw that point group. And I'm going to choose these corners. I'm going to say, okay. And bing, 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 bing. You see all of the corners had these points drawn there on that corner. And you can see, and of course, they look like little stop signs. And let's see, my wipeout frame, I'm going to say, yeah, turn that on. So there's actually a point that also has a wipeout. That's why you're seeing the property line, which does go to the corner, but with the point over top of it and the wipeout over top of it, it hides it underneath it. It's like you broke the line under that circle. All right, so now I've put those points down there and they show up as my map. It's instead of me having to go and drop a circle symbol on each one of these corners and hoping I catch them all, because right here's one that I would have missed because it's an actual point along this linear feature. That's the actual end of an arc, and then it goes into the straight portions, but it's not on an interior lot line. So by having that and done with these point groups, I was able to now draw all of these corners in, okay, so that I've got a nice little finished map. And what that is, it's not just a symbol. So if you double click one of those symbols, you can see it's an actual full point. There's a point number. It's got coordinates. It's got an elevation. It's got a description there. It's called P core because it was one of the line works, one of the corner points based on the interior lot lines. This one, 81, should be a description that says BDY. It's not one of the P cores, but it's still all part of that group. So that's a really nice and quick way of being able to choose those points. Now, and we could go through the exercise we want of say splitting this difference and making this lot line that's missing. What I will do is we're going to rotate this line from the center of this circle to the midpoint between those 2 points. All right, so that will create that for us, and we'll make that as a copy. So if I select that lot line and I'm going to rotate that, the rotation point, I'm going to hold the shift key, right click the mouse and choose center, and I'm going to choose that arc of the boundary. So that's going to be, starting back there at the radius point, and specify the rotation angle or copy or base angle. So I'm going to say C to make sure I make a copy of it. All right, and so now I'm going to choose, instead of typing a specific angle, I'm going to say B for base angle or R for reference in the AutoCAD version. And the base angle is going to be from the shift right click center of this circle to the end point of this line to the point that's halfway between those 2 points. So I'm going to say shift right click mid between 2 points, the end point of that line and the end point of that line. And so now there's that line rotated about that center to that midpoint. And it may or may not come up here and hit exactly on that boundary line right here, this arc. It probably does, but just in case it doesn't, I'm going to select it and I'm going to stretch it just a wee bit up here, and now I'm going to trim it back. So I'm going to say just a standard AutoCAD trim, and that's going to be one of these little tools over here. There's extend. There it is, trim. So my cutting edge here, and trim off that part. So now that goes as a property line that was missing. I now need to put a point on there. So if I draw locate points, and I'm going to snap to those endpoints, I'm going to keep those same settings there. I'm going to now turn point numbers back on, and I'm going to start with 201, for instance. I think that should be all I need. I'm going to say screen pick. And so I'm going to now go here. There's 201. And now here's 202. And that's all I need. Now, I can erase those and redraw them with the point number off, or let's just leave it on for right now. I'm going to go to 201, and there was no description there, but I'm going to, if I remember, my group corners had P core as one of those. So that is going to be the description. I'll give that as PCOR. I didn't do it in the drawing, just in the coordinate file. I'll now double click number 2, and it's also got a description P core, and I'll say okay. And I'll now even, let's just redraw 201 and 202 now that they're in the file, and we'll turn the point numbers off. We'll draw a range of 201-202, hit enter, hit enter. I could have frozen those layers, but I just wanted to have these to match everything the same way we had it. Now, if I look at those points, list points. Now, I remember I did not go back and change my group definition, anything like that. But I'm going to use a group of corner as my list and say, okay. And you should see now at the bottom, 201 and 202 automatically become part of that group because the definition for the group includes everything that has a description of PCOR. So even though we added the points after the fact, they still became part of the group. And that helps you to keep track of your points. Okay. So that will catch us up to that. When we come back after lunch, we're going to hit our terrain modeling better. But let me ask everybody too. You can go ahead and unmute and just have a little group discussion here. Does anybody have much experience in building surfaces yet? Yo, no, yay, nay.
No.
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 Okay, good. So we'll start at a fresh beginning. I didn't want to hold anybody up if you've been doing it for years, but so it's a really great thing to get a good handle on understanding. And so we'll step through that from the ground up. Okay. And then we'll look at the tools that we have to help us do that and help us see things in 3 dimensions. And then we'll go through that little typical workflow and exercises, and I'll point that out. And some of those we may have to leave, for you to do on your own after class someday, but you'll have all of the instructions there in the book. But we'll pick that back up when we come back after lunch. Anybody have any quick questions at all on anything?
I do. I can wait a second.
Okay. Well, I'll tell you what, I'll go ahead and declare lunch starting at 12:15. We'll come back at 1:15. And I'll go ahead and I'll keep the recording going. So what is your question? Or
Right, just the back over here when you were creating that second that lot line between lots 78 and 79.
uh-huh.
Okay, somehow I don't know if I just didn't find it in the AutoCAD version, but you copied the line between 79 and 80. Was that your initial generating command?
No, I did. I rotated that. So I selected it.
Mm-hmm.
Okay. And
Yep.
then I said rotate. So I say,
Right.
I use my rotate command, and
Yep.
it says, okay, I've got a point. What's my base point?
Mm-hmm.
Shift right click and choose center. So my base is the center of that circle. And now here's where the copy came in. Right down here below is I have to choose copy first. And so now I know to copy it. And now I'm going to also do a reference. And the reference angle is
That's
again
not what
from the
I'm
center.
seeing. Okay, I'm gonna execute that again. That's not what I'm seeing on mine. I mean, I use rotate. That's not what I'm seeing. So let me just
Okay.
select. In my case, right click, rotate, specify base point. I'm going to do a shift right click. And at that point, I have option of center or geometric center. And do you want me to choose geometric center or regular center?
It was regular center should work fine because it's but see, and I've got that same thing. Geometric center are for non-circular objects.
Okay.
In IntelliCAD, it's just one thing. Center means the centroid of a shape, whether it's a circle
Right.
or arc or
Okay.
okay. So
So
center.
use center.
Mhm.
Okay, I selected center. I now have rotate, specify, base point, of course, underscore center of,
Yeah.
and then that's where I guess it's something sort of breaks down. So I seem to have, I'm just reading what yours says as well. Okay,
Yeah.
but anyway, it just says a base point center of, so I'm guessing it means that highlighted line.
Yeah. So, well, you got to understand what it's asking you for when it's asking. Okay. So I'm going
Mm-hmm.
to select the object and rotate it.
Yep,
So now
I did that.
I'm in AutoCAD 2023. I don't know what
Mm-hmm.
version, but anyway. So I'm going to rotate and it says specify the base point. So the base point is this simply. I'm holding shift, right click and choosing center, and I'm pointing to this purple line, this boundary, because that's an arc. That's a part of an arc. So I'm going to say center of down on the command line. So if I pick that and I see the little pop-up that says center, so I know it's found that. Okay, so there it is. Now it's asking me for something else now. It says to specify the rotation angle. And by default, use east
Yeah,
or copy or reference. So I'm going to say copy. I'm going to say C, or I can just click it. All right, so now it knows it's going to do a copy instead
mm-hmm.
of rotating the one that I selected. So now that I've got that ready, it's back to asking me to specify the rotation angle or copy or give it a reference. And that's what you want. A reference means you're going to show it
Mm-hmm.
starting point and then show it the ending point. So I'm going to choose reference, and the reference angle is defined by, so specify the reference angle. Now I can either type the angle if I know it, I don't. The angle is going to be defined by 2 points that I click. The 2 points that I click are going to be shift, right click, center, and I'm only doing shift right click, so I get that little temporary pop-up. So I'm going to start from the center of that arc that defines the starting point. The ending point is going to be this end point of this original line. Okay.
Mm-hmm.
So that establishes the reference angle.
Mm-hmm.
Now it wants to know the new angle. And again, I could type it in or choose by points. And so all I need right now is 1 point because it's holding it at that rotation base point, remember? So I gave it a
Yes.
reference to this point, and I'm going to show it the next point. Okay.
Mm-hmm.
And that is going to be shift, right click, mid between 2 points. So I want to go
Mm-hmm.
to the middle place, the middle location
Mm-hmm.
between this corner and this corner. So I'm
Got
going
it.
to go over
Yep.
here. Do I snap to that? And I'm going to come back and snap to that. And it's going to go right halfway between them and finish the command.
And I don't know if I need to share my screen.
Yeah, that's fine.
I follow, but it's like the command drops
Okay.
after I do shift.
Yeah, go
Uh,
ahead and share your
I mean,
screen.
like very early. It's like it just sits there, like nothing happens.
All right. Go ahead and
Let me see. I think I have to move this. Okay, let me try real quick. And I apologize. I mean,
no, that's what you're here for.
okay,
Well,
select Windows screen. Okay. Are you able to see, looks like, yeah, it looks like you can see my
can.
AutoCAD.
Yes.
Okay. So, so anyway, that's the line I'm selecting. I'm going to rotate.
All right.
and select the base point. In this case, I'm going to now do a shift right click. I'm going to select, choose center.
Yeah, no, I can't see your pop-up. I don't know if you got another screen that you're using that on, but that's fine. But yeah,
Oh,
it
no,
should,
I don't see any other pop-ups either.
when you said shift right click, didn't you get a menu to pick from?
I did, and it was right on that screen. Here, I'll do it real
Oh,
quick.
okay. It may just be that it doesn't show. All right, so
Okay, rotate,
from,
and then, let's see. I'm surprised you can't see it, but anyway, I do have it. When I right click, I get that, menu that's floating. And do I, so then I select center. Can you
yeah,
see at the bottom down here where
yes,
it
it's
says
center.
center of? Okay.
Yep.
So at that point, it's like it just kind of, I don't know. I haven't been able to.
Okay, well,
So what would,
it's asking you to show it what you want to take the center of. So you need to now go and point to the purple line between
mm-hmm.
78 and 79. So right in there, once you're there,
Yep.
click it. Now it's established, it's found that center.
I misunderstood which center you're talking about. When I understand, I think I understand. Okay.
Okay.
Right. Okay. So the center line of this segment between,
Well, not the center line, the center of that arc, which
excuse me, the center of the arc.
yeah, roll it out, zoom out so you're up higher in the air and you can see where it's coming from. That's the radius point of that arc segment.
Oh, yes. Okay. I see up there.
That's what, when you said shift center, find the center of, it wasn't find the midpoint of, it was find the center of that circular shape.
Okay. I think because I hadn't zoomed out, I was
Yeah,
misinterpreting.
you weren't seeing where I was coming from, right?
Okay.
Okay.
Okay, beautiful. Okay, so I've got that.
So see,
And then now I want to copy
mhm,
because I want to copy the original line.
correct.
And let's see, I thought I put C. Yes, rotating a copy. Okay. And now I'm going to do a reference.
Yep. And
I don't know the angle. So now
reference
I,
is going to be what? In
yes.
words, what is it going to be?
So I need the initial reference angle, if I understand you correctly, to be, I think it was the midpoint between, and I'll show here, the far left of 78 to the far right of 79
So
lots.
that's going to be your new.
Oh, that's the new one.
So
I need the reference
the
angle.
reference angle is what is the angle now? The angle
Hmm.
now is from the center of that arc to that endpoint.
Okay.
Again, we hold the shift and right click and choose center and point to the purple line. Okay, and now we need to show at the other end of that line, which is the end point of the lot line there between 79 and 80. So we go over and hover there. There we go. And no, not perpendicular. Make sure you come to the white line. This is part of what I think's going on. You see the right now it's trying to go, it's trying to snap nearest.
Yeah, I
Because
can take
got
that
that.
off.
Yeah, take off nearest and take off perpendicular. You want
Okay, I've taken off
yeah,
perpendicular, take off nearest. Yeah, sometimes these get in the way.
yes,
Okay.
you're right. And so now you want endpoint though, so make sure that's
Yep.
on.
There we go.
There you go. So now that,
That's
and
okay.
now zoom back out a little bit and you can see what it's trying to do. See, it's trying to now go to a new angular location, and that new angle is going to be shift right click
Okay.
and choose
And
mid between 2 points. And that,
now that's from here at 78 left, 79 right.
yeah, make sure you're getting the end points now. Looks like midpoints of those segments. So go back and point to the first. Well, I mean, you can leave those on. Just make sure that the one you get is the input. Yeah, right there where it's all right. Click there. Looks like you're also getting the point. Now click on over there, and you don't have to actually go to the.
Mm.
You don't have to hover over the exact end, but you
Hmm.
can nearest to the end of that line. If that's the first snap, it'll find that would have worked just fine.
Okay.
Okay, so that's exactly now. It did exactly what mine did.
Okay. And I think part of that was that I didn't, I don't know. I just, anyway, I get it now,
Well,
right? With the
yeah,
radius of that arc, and I had to zoom out.
Yeah, you're thinking about the center as being the middle point between something, and what I meant was if that were a full circle, it would be the center point of the circle.
Yes.
And
Okay.
that's, yeah, because those lot lines are radial when you've
Mm-hmm.
got a typical, when you've got lots that are based on uh, arcs on the boundaries, on the outside boundaries, we typically set those lot lines as being radial to those arcs. And that's just an assumption. They're not always necessarily that way, but the assumption is that it was. And so I wanted to recreate my missing line as, taking that one that was missing and just swing over and split the difference. Now,
Okay.
we could actually probably, um, see how well we did it. In fact, if you let me,
Mhm.
uh,
Oh
let's,
yeah, I can trim that because it went out. It extended it just a little bit,
well, it maybe
or
let
I could just back it up.
Yeah, I mean, it might be longer than, or it might be part of that circle resolution, but in any
Mm-hmm.
case, if you go to the intersection of there, it should, um,
Oops. Picked up extension.
yeah,
Let me fix that. Oh,
need to undo.
yeah. Okay. And let me fix the extension. That way, when you know it, the one time's like normally it's difficult to get extension to work. The one time you don't want it to. Okay. And then put my intersection back on. All
When you
right.
turn those on by clicking that, it turns them on,
Mm-hmm.
it leaves them on. If you hold the shift key and right click the mouse, it only turns it on for the duration of that command.
I see. That was the purpose. It's not just like it's another place. It's temporary versus continuous.
That is correct. And that's why I use that one separate. I usually only have endpoint, midpoint, and extension are the only ones I keep running. And if I need the other ones, or if I get into a situation where maybe I'm creating a lot of perpendicular lines and I want to set perpendicular, then um, I'll turn that on, in the settings the way you've been doing it. But if I just need it temporarily, I'm going to do it from, um,
Hmm.
now you see why nothing's changing? That's what
Yep.
I wanted to see that happen here
Yeah.
because it's not really out past that. Stop a minute
Mm-hmm.
and
Do a
press it.
regen.
Yeah, do a regen and you're going to see that circle snap
Okay.
back the way it's supposed to be.
So
That's,
I hadn't. So after I zoomed in to look at it, then I
yeah,
should have regen to verify.
yeah. Or you could type that view res and set the number up higher and make sure your
Yep.
automatic is on. It's just one of those limitations of AutoCAD because AutoCAD's never gotten away from display list technology and they don't know how to handle circular
Mm-hmm.
geometry.
Okay.
Anyway, I have a couple of bugaboos with Autodesk over that, but that's beside the point. We're not sitting here. The point of this is not to beat up AutoCAD. All
Right.
right. So,
Okay.
all right.
What
Well,
did it stop sharing
it did.
for
Yes.
you? Okay, perfect. I that was the main thing. I'm sorry it took a few more minutes.
No, that's fine, and I'm glad you.
Anyway, that's
I don't
that's
mind.
great.
You did.
And thank
I
you for recording that.
certainly. So that's going to be there. They're going to have access to it. Just in the interest of time, I'm not going to extend lunch till.
No, 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 no.
Let's just come back at 1:15.
Yep, I'll see you at 1:15. Thank you.
Okay, you bet. Take
Okay,
care.
bye. Thank you.
Good heavens. You know what happened? I started it and then I paused it until we got the other guys back after lunch and I neglected to put that on. Gosh, thanks, Gretchen. I'm so sorry. Um, what we've gone over so far is all going to be second nature to you anyway, by the time you've worked with this a couple of times. But that's not to say that it wouldn't have been nice to have had in the recording. I do apologize there. And thank you so much for pointing that out. That's why I said, yes, we are recording because I remember turning it on, but we turned it right back off and then neglected to get back my apologies. Anyway, so now that we're in here and we're going to use this second icon from the left, that is the X, Y, and Z icon. Notice what that does to your cursor as you hover the mouse. When you're over top of the middle part, when you're sort of over the data, so to speak, and it's not exact, but it's sort of in general, the cursor takes on the shape of an X and a Y. And that's what you see on the screen. when you see that, if you then press and hold the left mouse button, it's only going to allow you to move that information along those axes. So if I press and push it up and pull it down, it's only moving along that Y direction. If I press and hold it down and move it back and forth, you would expect it would be moving in that left-right direction, but it's not moving like that in that direction right now, is it? And the reason is, if I look over here on the right-hand side of my panel, I see I've got that axis locked. So if I unlock that and now go back and do it, you see now I can move it this way and I can move it this way. But the reason I have that locked and the reason it is by default is that that is the best way to be able to position yourself anywhere you want in the drawing by remembering a little trick. We'll talk about that in just a second. So the other motion then that you can use here is to, well, not only, move it like this up and down, but then once you get it to a certain place up and down, you want to be able to maybe spin it around. So that's it. If it's over the X, if it's over the data and it looks like an X and Y, that's what you're getting for motion. If you let the mouse button up and then push the mouse down to the bottom of the screen or out to the side or up to the top, you see at some point it changes into a Z with a double-headed arrow around it. Meaning if you press and hold the button on the mouse and move it, it's only going to be going around that Z axis, okay? Now here's the trick and how to remember how to do everything and position yourself exactly where you want to be. Let's go over here to the right and let's choose the far right icon on the second row down and do zoom into plan view. Let's make sure the upper checkbox where it says ignore zero elevation entities is checked on so that we are not looking at anything that does not have elevation. And let's see what we have and how to control this motion. So let's now go back and grab the second icon from the left, the top row of those two horizontal rows. And let's put the cursor over the middle part of the data to where it turns into X and Y. Now here's the trick. You're going to consider, or you're going to think in your mind as you're looking at this data, that you are standing in your driveway and what you're looking at on the screen is your garage door. Somebody came and painted this map on your garage door maybe, and you're standing there in your driveway and you're looking straight ahead at that as a vertical surface. And so what you want to do with the cursor as XY, you want to reach down here toward the bottom of it. So before it turns into the Z cursor, while it's still X and Y, you want to click and hold the mouse button and you want to only push it up. So you're going to pretend that that's your garage door and you're going to be opening that garage door and laying it back almost flat. You don't want to go all the way horizontal, but just something nice and oblique about like so. And you can go and grab an extra, another nibble if you need to. All right. Once you have it laid back at about that 75 to 80 degrees, let the mouse up and put it down at the bottom where it turns into a Z. And now you can go back and forth. And so you're going to say, line yourself up. And now when you get sort of where you're wanting to go, you can use the wheel to pan and zoom, just like when you're doing your regular CAD work. So I'm looking down this particular road right in here, and I'm looking at, looks like some concrete walls maybe right in here and curb lines and that sort of stuff. Well, so maybe I want to be looking, down this road over here. And so here's what you simply do is you're looking over here, you're evaluating, you're going to say, okay, I want to look somewhere else. We'll just roll the mouse back out, go back to that same idea that you're going to just sort of lay these things back at a particular space and then go down here and line yourself up and just sort of fine tune. So I'm going to line up pointing down this particular road now. Okay. So if I want to, instead of looking down that road, I want to look up this little valley where the pond is over here. So I'm going to zoom out enough to line up here and see that and then pull it down. And I say, okay, there it is. Now I'm going to roll it back up so it's laid back fairly obliquely and then line myself up and then just zoom into it. Okay. So always keep that idea in your mind that you are standing in your driveway and you're going to raise that garage door up and look at this data. Okay. Now, you can see a lot of this data is contour lines. I also have a bunch of drawn outlines. These are those 3D polylines. They're break lines. So, and I've also got these purple points that you can see. So if you look over here at a couple of other things on the model tab, you see I've got layers, I've got points, polylines, surfaces, text, blah, 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 and then layers. So I can decide to freeze one of those layers, for instance. If I look at this layer, and I don't know what layer it is, I'm going to go back to view control. I'm going to choose this arrow, and I'm going to point to say that little white line, and I'm going to see down at the bottom of the screen right down here, it's going to say, hey, that's a polyline. It's on a layer called V-topo-BKLN. Okay, great. So back to my model, I'm going to look for V-topo-BKLN, and I'm going to double click that. And so that will turn off that layer. Back to view control. I now have my second icon from the left, and I can look at that. Or I can look at that one being on, but I could turn off the points. That was the DTMP. Or I could turn off the major and minor contours. I've got one more. Oh, there it is. And maybe the points. And so this is what we're left with just a bunch of 3D lines that define the edges of the ground along that site. And those are actually all you really need. Now you do need those points that are off there by themselves, but this is all the stuff that you need to form the surface. But when we look at it like this, it doesn't really look like what we're used to, right? What we're really used to seeing most of the time are contour maps. Well, let it. And let's turn off that V topo break line. Come on. There we go. So I'm double clicking those. And I'll turn off the points too. So now this is really what we're normally used to seeing. And that's sort of, you know, I can look at that and I can visualize how that land looks in there based on these contours. Okay, but mathematically, I need to be able to reconstruct some kind of a model that the computer can then look at and figure out what the elevations are. And I can do things like compute volumes in between multiple surfaces, things like that. Okay. So to be able to do that, remember, and I'm going to just hit the exit button in the lower right-hand line of icons to exit the viewer. But I've used the viewer, I've verified that things look good. I'm getting ready to start to build this surface, but I've got a couple of choices here now. I've got data in my drawing in the form of those 3D polylines. I've also got data in the drawing in the form of these 2D, but at the correct elevations polylines that are the contour lines. Okay, they're both there. They both represent the surface, hopefully as judiciously as it can. But the contour lines are less accurate than these other break lines because all they really say is what the elevation is along their length, and it's saying it's the same elevation everywhere along this path. Looking at the next parallel contour line, it says, okay, the elevation changes from this line up to that line by 1 foot or 2 foot or 5 foot, whatever your interval is. And the assumption is it makes everything in between those two lines, it assumes it changes linearly with no sudden and abrupt changes. So really the more accurate are these sort of random looking white lines because they do go up and down and catch those little points and the high points and the low points. And so they're not sort of, relegated to the, um, it's almost like quantum energy states in an atomic model where these things can only have discrete values. Like contour lines are like that. It can only be like 1013 or 1014. I don't have a contour line that's 1013.372. I've got the 13 and a 14. Okay, so the big assumption there then is that the model that you're building means halfway between those two lines is exactly, say 13.5 instead of 13 to 14. So we're saying it changes linearly when that's not really what typically happens in real life in Mother Nature. So these white lines are really the source that we're going to use. So we're going to need to turn off those contour lines because if we try to build a surface using all of this data, these things are crossing each other, and where they cross, if they're not exactly, and I mean exactly out to the 100th decimal place, the exact same elevation, it's going to complain and say, hey, I've got a unknown here where these cross, and you need to tell me which one you're going to use. That's sort of the dialogue that goes on. So if you want to consider that as an option, then when you run the command, and we're going to learn this command and go through it many, many times here, we're going to say triangulate and contour, and it's on our surface menu. I'm going to go to the surface menu, and I'm going to choose triangulate and contour. And I'm going to turn a couple of things off for right now. I'm going to start you over here on the right-hand side, go all the way to the tab that says selection. Make sure that neither of these top two boxes are checked. Then I want you to come back to the contour tab and uncheck the upper box where it says draw contours. I don't want to draw them yet. We're just going to build the surface. That then you can verify if you look at labels, the whole page is grayed out. And now really what we're controlling is going to be done from this particular screen. So to match these, and you can see you can draw all of these individual things. You can draw the triangulation lines, the 3D faces, all of that kind of stuff, but there's no real need to because the 3D viewer can show those to you by reconstructing them in memory, and it's not hogging up your drawing. So I don't actually turn those on very often at all. I do want to do this. So I want to write the triangulation file. I'll turn that on. I'm going to hit select, and I'm going to give it a file name when it comes up and asks me if it's ever going to. And see, we used to teach our classes in training facility, actually where this file was produced down at T3 Global down in Bridgeville. And the students would come in and get a hotel room and stay, for the duration of these classes. It was nice because I didn't have to rely on Zoom, and that's what holds, that's what creates these little lags sometimes. So apologies for that. All right, so now this has popped up. I'm going to, again, I'm looking in my proper folder, my data sets, and I'm going to call this EG-1, existing ground, take one. And I'll say save. Now, the next thing I want to look at is to uncheck these others and set my shrink wrap perimeter reduction to none and erase previous contour entities. I'll go ahead and just say turn that off for now. Right here's that switch. I want to ignore zero elevation. So I'm going to have that on so I don't have to worry. If it is at zero, even if I select it, it won't use it. So that's a nice switch for me. I'm going to specify the maximum triangle edge that I want to consider would be, say, 2,000 feet long for triangles in the middle, in the interior part of the data, and 2,000 feet long for things out on the exterior end of the data. And we'll see how that may apply. It's really something that can sort of ignore. It's just a way to keep from producing huge long triangles. And I'm going to uncheck this densify break lines for now. Just leave these two on. I'm going to write the file, give it a file name, ignore the zeros. These two choices are here are none and off. Everything else is unchecked. I'm going to say okay right now. Read the prompts, and this is where it gets important to always read the prompts and the line above. So it says select entities. Okay, you might assume you know what it wants you to select is the data that you want to be using, and that is indeed what it's saying, to select the points and break lines to triangulate. So let's just go out here and start in the lower left and click once, drag up to the upper right and click again to say, look at everything in that window. When you're through selecting, hit enter. And now watch the errors that are going to pop up. And what up there in your error list looks like the most prevalent that you have are these crossing break lines. I have 334 of those errors. And if I expand that little plus mark, I see that they go from the highest difference. So right here at this one at 4.409, you can watch a little marker move around in the drawing, wherever that happens to be. Right there is at 4.049. It's right in there. I can zoom to and then say zoom in with these buttons here on this left. And I say, oh, okay, so right in there, I've got a line that crosses something else, and it's 4.049 feet difference. My guess is that this, which is a utility pole block, and I see it has an elevation down here of 0. So it's not really that's crossing. Maybe there's something else. And I look at, say, this line and this line. So this line, and that's one of these contour lines, comes in here and it also crosses this line, which is a 3D polyline. Okay. And where they cross, there are 4.05 feet difference in elevation. And I can see right here on the contour line, that's an elevation of 1,300. If I want to, say, figure out what it is on the 3D polyline, I can't really tell. There's not a vertex there. So if I go to my inquiry drawing inspector. And if I look at the elevation, well, there it is. I don't need the layer name. And I come down here and I see, remember this contour line was 1300, but this line that I'm looking at here, you see, it says it's 1304. The one over here says like 1299. So this is the 1300 line, this lower one to the left. That's what made that contour come all the way up there, as it's assuming to be 1300 feet. But this line is 4 feet taller. Well, how can that be? What is it? Well, let's select. So I'm going to do a little crossing selection of those things here. I've got contours. I've got the contours and I got those two lines. That's all I'm going to have selected. I'm going to go to view, 3D view, drawing viewer. And let's take a look at what we have. So if I remember, I'm pushing it up by standing in my garage. And now I'm going to zoom in and I say, oh, I think I see what's causing this. Is that, oh, that looks like maybe one's the bottom of the wall and one's the top of the wall. But the contour line shoots a little bit past that outside bottom of the wall. And it goes all the way over and touches, at least, it might go just a little beyond as well, this top of the wall line. Okay, so it goes over here and maybe it's sticking a little too long to go over there. So I can't have that happen. I would need to be able to pull that back off of there so it's not such a difference in elevation. And I would have to do this for, 334 different places, although it gets very quickly a little bit more reasonable down into the similar type numbers. But the point is, where you have all of these white lines that are the break lines that follow the ground feature, and then you also include the contour lines, which are usually sort of perpendicular to those break lines, they're going to cross. And if they don't cross at exactly the same elevation, it's going to create an error because the computer can't tell which one of those things you mean, which one of those two differing elevations is the correct one. Okay, so the people that put all this data together, when they created the white lines, they are looking in their special instruments and they're putting that little floating point down on the ground. They're walking it around. They're collecting those break lines and they're experienced at it and they're good at it and they know what they're doing. So that's what we're going to be using. The contour lines that you see, on the other hand, are the computed result of looking at those white 3D break lines and the individual points that are out there in that file as well, those little purple dots. Okay. And those were compiled by looking in through the eyepieces of the instrument and putting the floating point marker in their models down onto that ground image and recording that as a point location. Okay, so they're very good at this kind of stuff. That's what they do. They're now looking at that data. It's gone through and connected up all of the triangles and used the break lines to keep points on one side of the line from looking across and seeing points on the other side. So it's done its job. It's put all those things together. And then it's going to calculate based on that model that it has in its memory. It's going to then calculate where those contour lines are supposed to go. Okay, where it basically interpolates, where on those lines between the points of all those triangles, where do you find the elevation of that, say, nominal, unit value of one particular, elevation. Where does that occur on those lines? And then it connects up all those little tick marks and puts them into this line of constant elevation. So all of that's just a fancy way of saying contours and contour lines are an output. They are the result of the process of reading the data. They're not the input. They should not be used as input. They should not be the source that we as users are going to look at and say, oh, hey, these guys were so nice. They gave us a contour map. So I'm going to take those contours they gave us and I'm going to use them to create a model, to create a surface model. You can, but it's dangerous because it doesn't have any break line data and it assumes all of this linearity between lines that they may have, intended to just, show trends. So you always need to use the more accurate form of the data, which is going to be those 3D lines and the points, and we're going to disregard the contours other than as a way of checking what we come up with our own uh, methods of modeling the surface, which could be that we're using the design contours or some kind of process and saying, yeah, that's what I want my finished world to look like. Go ahead and create a surface out of that and bada bing, bada boom. But usually we're going to be working with points in 3D edges and 3D lines to define those surfaces. Okay. So what do we do then? If we have this, I'm going to go ahead and exit that. So I've got these two different sources. I've got all kinds of conflicts. How would I fix that? What would I do to eliminate getting that error? Anybody? This is your mid-afternoon quiz. And the answer would be, yeah, this is why we like this is why we like the one-to-one classroom, is so we can actually see, is everybody getting what we're talking about here? But if we're going to get those kind of errors because we select something that includes, say, this line, and it also includes, say, this line, is we need to not include one of those lines, right? So they don't cross. We can't have it cross and run the risk of it crossing at a differing elevation. So how do we do that? Well, we got to turn one of those off, one of those sets of information that's in this drawing. We have to turn it off and only consider the part that's left. And so remember how we did that earlier with these view tools? If you freeze a layer by pick or by selection, so let's freeze by pick. And remember, we said the contour lines are not all that accurate because it assumes everything in between adjacent contours is a linear change. Whereas, this white line edge might pick up a high spot or a low spot in between the contours, but the contour lines know nothing of that little high or low spot. And they were the output. They were the result of originally looking at the white lines to begin with. So I'm going to want to freeze my contours. So I'm going to pick the one, which is the index, its label, the intermediate, and I'm going to zoom out here and I see, all right, I've also got these in these obscured areas. So I'm going to pick one of those and then one of those. And that looks like it's got everything out of the way. I've got all of these little pinkish purple points, you see, that we're going to be using. Because it's going to select those points and it's going to start drawing triangles to those points. And it's going to start drawing triangles over to these, all the little vertices of these white lines here as well. That's how it's going to start to build that as a surface. Because I'm looking here, if I'm sitting at this point, I can see all these points along this line here, and those are perfectly legitimate points. to form, to form the triangles between. But I can't sit on this point here and look across this line and see this point way over here on the backside and say that is a linear change, because it's only going to be able to look across there if that line is not already drawn. Well, you can see it's drawn there, so it's going to keep me from considering these points on the other side. So that's why we use those, and they're called break lines, because they're going to break the process of modeling that surface. All right, so now when we triangulate and contour, let's go back to it. Surface, triangulate and contour. I'm going to leave everything exactly like it was, and I'm going to say okay, and it's going to ask me to overwrite a file. So that exists, and I'm going to say, yep, it's okay to overwrite it. It exists, but it had errors. And it says select the points and break lines to triangulate. I'm going to grab everything here, draw a window around it, say okay, and boom, it's going to come up, and I've got just 5 errors. I've got 3 places where they cross, 2 vertical edges, but you see they're really close to being 0 elevation difference. Here's the one little spot. I'll zoom to that. And it happens to be where this is a head wall for a bridge. I'll go ahead and show you that in our 3D viewer. And I said in a bridge, I meant to say in a culvert. Let's go back here and do this the right way. So what's happened is the people making this model, they got in a hurry and they let those lines cross, and they are not supposed to. So all I would need to do is, I see that this elevation and that grip, let me also turn off my drawing inspector. That elevation is 1313.13. That's 1313.04. So this one's higher than that one. This one is 1363. This one is 1393. So this one is higher than that one. And you see how they crisscross here. So what I would need to do is basically take one of these and instead of having it crisscrossing and so they intersect themselves, I'm going to make sure that they are, situated in the right orientation. So that now would be closer to the way that head wall actually exists. Okay. Doesn't really, it was done sort of in a hurry. I'm pretty sure that they're have a problem, but I've eliminated the error. So if I go back to surface now, triangulate and contour, triangulate, we're going to say okay, and yes, repeat to overwrite the file, select our data. I'll just type the word all, hit enter. And now I'm down to just the one, and it doesn't even show me where it is because it is, I got to open this up and then get it. It's 0.08 feet, so it's less than a tenth. I zoom to it and zoom in, and I see really what's causing that is the fact that it scooches over the edge just a little bit. So the fix to that would be right in there, is I would just basically, take this 3D polyline and pull it back a little bit. Let me like so it doesn't cross. You do that, you go through here and you'd find this couple of little spots. All right, I'm not going to bother fixing those. I've done that. But now what do we have in our bag of tricks that we start to work with? We have that file called EG1, right? Let's look at what it looks like. Go to the view menu. 3D view, surface file viewer this time instead of drawing viewer. And we're going to find, it's going to ask us for a 10 file to pick. And we'll choose that file that we just made called EG-1 as soon as Zoom lets me have my computer back. This is just almost unusable. All right, so there's that. I open it up. Now you're going to look at this file, and now we're going to get a slightly different look to what you saw before. And it might look like this, where you're seeing all of the triangles that formed. And if you were to turn this on and look at all of those different things in the drawing, you would see all those little pink points show up, all of these points down in here. And all of these points along these edges are all of those vertices along those white 3D polylines. And you can see that stuff almost as if it's been, constructed out of these individual triangular pieces, okay? Now, if yours looks like that, notice one of the icons, this one that looks like a fishnet with the squares colored in, is something that's going to allow you to view it as if it's solid. And I'm right now over this blue circle, and I'm dragging the little light source around to change which side I'm casting shadows on. Think of that as maybe the sun up in the blue sky, and the blue circle is the earth. But you can see very clearly, the additional precision that you're going to get out of that. And it's actually made this as a model so that I can go anywhere along that model and find out what those elevations happen to be. If I go to my inquiry menu and say, well, actually not on this. Yeah, not on this menu. I need to look under the surface menu, I think. Will it give it to me? I'm looking for my surface inspector. I know it's in the civil. Um, yeah, I don't really see what you can. There's some other tools in the other modules, like in the civil module, that I can track, and it will read the elevation of this model at any location. Even if there's nothing in the drawing at that location, it will still read the triangle that lives underneath that. You've got another thing, if you wanted to take a look at some of the surface information, is under your surface menu down toward the bottom part of the menu. These things, everything under this line has to do with profiles. So I'm going to do a quick profile. And I'm going to use the surface file as my source here. I'm going to choose the surface file, the first one I'm going to look at. I'm going to click the first button, and it's going to eventually ask me for the file. I'll tell it that EG-1 go ahead and close that and see if I can't restart this. Yep. See there, it's decided to. And I'm going to say, okay, and let's see. I want to look at this surface from, say, from here across to here. I hit enter, and there's my little tracker. And if I want to move that, I've got this adjust alignment. So I can move this around and look at my little profile view below is it's going to be changing in real time. So it's another nice little way of evaluating whether you've modeled your surface correctly. If I look at this, here's a very common source of errors. And if I go up here to, I'm going to just click across up there. And I'll click across here. So I'm now, as I'm looking at this, I'm looking across that curb island. And if I move this around, you can see I'm tracking right there between those two lines. That's my little curb. And I see that it sort of has this drop off. Let me put a ×1 exaggeration instead of a fit. And I look at that right in here. So you see where my blue crosshairs are in the profile view down below. And I see that slanted line, and I see that's rising between those two drawn lines in my drawing. So that's the actual curb face. Same thing over here on this side now. And I'm showing that curb as being laid back at a 45-degree angle. Well, that's a wedge curb. That's like your asphalt curb where it's pressed back, you know, it's a triangular shaped curb. And in this particular case, that is correct. Okay, but sometimes some people will give you, surveyors will give you this figure, and they'll say that that curb is a square curb. And what they mean by that, and what they want you to do is that you're going to have to compute this surface with this bottom point right here, the bottom of the curb. And instead of then connecting up to the top back of curb, you have to come up with the top front of curb. So you would have to create that additional line in between the face of the curb and the back of the curb to make that model as a square curb. Okay, so it's a little bit beyond what we're doing in today's class, but it's more of what you would get into in the civil class as you, in the 3D modeling class, as you learn some of those tools as to how to generate those lines. But at least now you've got some tools that you can use to help evaluate what these are going to be doing and whether you've modeled things correctly. So now you've done some modeling on here, and I'm going to let you, again, we were kind of pressed for time here for today's exercises. There's a really nice little section in here that talks about cutting out these extra triangles in here, and they're triangles that actually formed in here. We're going to use those for boundaries, and it's talking about drawing shrink wrap boundary around the data and all that. So we're not going to take the time to do it, but it is discussed in the exercises. You can learn about that as well. And there are some tools that the command itself, the triangulate and contour command, will automatically compute that for you. And that was right here under surface, triangulate and contour, where it said shrink wrap perimeter reduction. I could have, instead of saying none, I could have said medium or high, and it would have gone through and put an outside boundary around all this data, tucking it up into these inset areas and preventing these long, skinny triangles that you see when you look at the surface. All right, so if I load up the surface, it's easier to see if I turn this off. Yeah, you see these long skinny triangles out here, and now they formed because when it's sitting on this point out here and it's looking around for other points to connect to, it looks up here and it sees these points way over here and it says, okay, I'm going to make that a triangle edge. Those triangles are really sort of invalid. We don't know anything about those, about the ground in that area. Same thing down here. I've got these long skinny triangles, and you can either choose to ignore them, manually take them out, or use those commands like that shrink wrap reduction. Okay, so read about that on your own and um, see about some of the tools that you're going to have to go with to be able to, sort of evaluate these models that you're building. Okay. So I'm going to go back to view and I'm going to say thaw/on all layers. And I'm going to turn off now those white 3D polylines and the pink little points that are scattered throughout everything. So I'm going to go to the view menu and choose freeze by pick. So I'll pick one of those white lines and I'm going to pick one of these pink dots if I can get down here and find one. It's sort of hard to see. There it is right there. Okay. So really it's just these two layers, VTopo break line and VTopo DTMP, which stands for Digital Terrain Model Points. So those have now been frozen. And that's taking it out of our way. And I'm doing this because I want to show you a real quick little design tool here and how you can use it. And because now you've made a surface now called EG1. So let's build a little pad. We're going to create this like it's the edge of a parking lot. We're not going to do all the refinement to it yet. But let's go on the surface menu and let's choose design pad template. That's going to be the command we're going to use. So we're going to use that to set some kind of outlined area that we're going to say, use this to make a building pad. Maybe it is a building, maybe it's a parking lot boundary. So the first thing let's do is draw that. So I'm going to draw in the draw menu a 2D polyline, and I'm going to put this on a layer called C-PKG for parking dash no, what you call it, EOP for yucks. So okay. All right, so I'm just going to come down here in this sort of flat area in here somewhere. And I'm going to say, so here's a parking lot over here, and it came off of this area. I'm going to say, well, let's just let's draw something that's sort of like this. Maybe it comes up here, and then we say there, and it would enter. Okay. So, we've got that. We've got to, build our truck ramp or whatever we got coming in here. So we've now got this as a shape that we want to make into a parking lot surface for perhaps. Okay. So just like we did before with these white lines, we need to give this thing some elevation. Right now, it's just sitting at 0 elevation. It's a polyline. We need to tell it what elevation it is to be able to create that to use that to generate a design surface, and then we can calculate earthwork between the two and that sort of thing. Well, we have a number of tools of doing, for doing that. We can say, we can look at this and see that here's the 1310 contour right here. Here's the 1315 contour. So sort of in between here, I got 10, 11, 12, 13, 14. So it looks like maybe, say 10 to 16 is up here. So let's see that 10 was in 3B. So 13, 14 might be about the halfway spot for this elevation. So I might then say, just select that and put it at elevation 13, 14 as a single elevation. Okay. That's one way to do it. We take a look at it to make sure that we didn't mistype a number. So I did a crossing selection of all of these contours as well as that thing that I just created. I'm going to go to View, 3D View, Drawing Viewer. And I'm just going to use this to verify. Well, it looks like I've gotten way out of whack here. That is an 13144. So you see, there's a perfect example of why I should always get in the habit of viewing what you've done. See, that's way too high in the air because of a typo. So if I select that again now and I look over here, I see 13144 when it really should simply be 1314. All right, now we'll try to look at that again one more time in my 3D viewer. And now we're looking a little better. So I'm going to look at that and see that it is sort of halfway in and halfway out. Okay, exactly what I was going for. So now I can simply do a number of things. I can say, all right, I've got this little flat area at some given elevation of 1314 and 13, it's 1314 all around the edges of it. How do I tie that into this existing surface? Are any of you guys doing any of this kind of stuff at work now?
No, I'm not.
Not really? Okay. So, but how would you do this from a workflow perspective? If I could stand out there on the ground and walk that yellow line and say, I'm at 1314, what question would you ask yourself if you had to step away from that platform and hit the existing ground? The question you might ask yourself would be, well, am I stepping down or am I stepping up? And if so, how far out do I need to step until I run into the existing ground, right? And so that's going to be what we call a slope interception or a slope intercept method. So I'm going to start at that 1314. I'm going to create where it hits the existing ground from that given a particular slope off the edges of this pad. Let's say I want to do a 3-to-1 side slope from there. Number of ways I can do that. I can do that through the edit menu, 3D polyline. I can offset a 3D polyline, even though it is a 2D, but when it hits, I'm going to find out where that is in 3D. And so here's my method. I can go by an interval at a certain slope and a certain distance away. But the one I'm after is surface. And I'm going to now choose surface as my methodology. And I'm going to say, okay, go ahead and do that. Now it says round the exterior corners. Right now I'm going to say yes. Slope format is going to be in a ratio form, so it'll be a 3-to-1. So I'm going to select this polyline to offset. And it's got some kind of a interrupt. All right. So I'm going to offset that polyline, and where's the surface target is right here, EG1. I'm going to open that up. And it wants to know, all right, what ratio do you want? If you're in fill, I'm going to use 3:1. I could just type a different number. In fact, let's use 4:1. I'll type 4. And it goes, okay, what if you're in cut? Well, let's also keep my cuts down pretty flat as 4:1. And it wants to know, okay, which side do you want to go to? Now think about this. I said, whether you're in cut or fill, I want you to go away from the edge at a 3:1 slope, meaning every 3 feet you take out, you're going to go up or down 1 foot. So I'm going to do that until I run back into the existing ground. Now, of which side do I want to offset? If I point to the side of the ground that is on the outside of this yellow line, that's going to make this into, say, a little tabletop. And that's what I would like to do. But if I picked it on the inside, that would be like I'm designing a pond. You get what I'm saying? Or maybe, a borrow pit that I'm going to do a little excavation. So, but for now, let's go to the outside. So I'm going to go out here to this outside area, and it calculates that very quickly, shows it to me, and asks me to pick another one. I don't need any more. I'm just going to say, okay. Now what this is done, I'm going to pull this out like this. I haven't made any surfaces from it yet. I've just created line work. So I'm going to select these and look at it in my 3D viewer. And I'm going to see that, okay, so you see how that was that flat elevation, and it had to go down here on this lower side until it hit the ground. And then up here on the upper side, my pad is actually below, because that was an area where I was in cut. All right. But that's a good verification. That just shows me where that is. Now that's great. I can now make another surface using these 2 items. So we build all of those triangles, between those 2 things and make a surface out of that, and that would be perfectly all right. And I could use that to build that surface. In fact, I'm going to do that. I'm going to go to surface, triangulate and contour, and this time where it says select a file, boy, this is going to be. When we stop for a break here in a minute, I'll restart my computer, see if I can't get something recovered. All right, so I'm going to call this one, say pad -1. And I'll say, okay. And I'm going to choose this guy and this guy. And I got no errors. I see up here that it, in fact, writing triangulation file, pad 1.10. So everything apparently said it worked. Let's take a look at that in our 3D viewer. 3D view, surface file viewer. Now you're going to see something sort of strange here. When this comes up, it's going to give us some triangles, some really large triangles, but sort of small in number anyway, across the bottom of this feature. See, they're very large triangles, but there's only 4 of them across the bottom. And when I look at it like this, well, it looks fine. It was a flat bottom surface, and that may be okay. Okay, and I can change, remember, I can change this around to sort of get some different shadows cast on across. So I've got that nice flat pad it's in fill on the bottom, on the downhill side, it's in cut on the uphill side. So that's sort of what I wanted. And that would be fine to work with like that. Again, I've got these types of things I can also verify. And you can see that bottom footprint. We looked at that earlier as well. So that helps to visualize it. But here's another, all very much the same type of tool. If we did surface volumes by these volumes by triangulation, if I use this two surface files, it's going to ask me to choose the existing ground and the design surface once the dialog comes up here. All right, so right up here at the top of this stripe, it says select the existing surface. Well, that's going to be my EG one. I'll open that. And it comes right back and asks me for the final surface. That's going to be my pad. I'll say open. If I have any inclusion or exclusions, don't really have any. So I'm going to select those. I can set shrink and swell factors. I can compute cubic yards or cubic feet or both. All of these different things. The tonnage, if you know the density of the materials, you can calculate the tons. You can do all this kind of stuff. For right now, I just want a couple of numbers. I'm going to say okay. And there it is. It says, okay, you're going to have to cut 300 yards of material to build that structure. But you're going to have to fill 1,600 yards. So it's mostly fill, mostly cut. And so how I would go about to balance that is, instead of having to do so much fill, I would lower the elevation there. And here's the nice little thing this report gives us is it also calculates the area in cut and the area in fill. And then it gives you this next little block down in this block, sort of the average cube that would, if you could squeeze this all down into a regular cube, it says that there's an average fill depth of 2 feet, average cut depth of less than a foot. But if you were to change, and it says, see, right now I have to bring in 1,300 cubic yards of material to build it. But it says if you would change the elevation 1.188 feet of that surface, not just the pad, but that's a good place to start, then you might be able to achieve a balanced site. And it's telling you that then based on that, for every 1/10 of a foot you go up or down with that site, you're going to be either gaining or losing just over 100 cubic yards, 110 cubic yards. Okay, so that's something that gives you a nice little design guide on how to go about doing some very simple grading work. If you had the civil modules, it has a tool that lets the computer automatically find that balance. We don't necessarily have it directly, but we have it sort of. All right, and I'll show you. I'm going to select this outside boundary and delete it. We want to do a similar process, but we'll call this surface pad 2. We're going to go to the surface menu, and it's called design pad template. Now, the thing that Civil has that Survey does not have is design pad, or is edit design pad. And it lets you go back in after the fact and let it run the earthwork and the adjustment to move things up and down, et cetera, et cetera. But for now, if I do a design pad template command, I'm going to target a surface file. I'm going to set my perpendicular direction or my slope projection perpendicular to slope. My design slope format is going to be by ratio. I will then uncheck all of that business and say, rounding the exteriors, draw the side slopes, erase any previous, and color the slide. All right, that's all good. I think that should work in general. Let's see. What layer did I put this on? It was C, parking edge of pavement. There we go. All right. So now, after I've run that and said, okay, I read my prompts down here at the bottom and it says pick the pad polyline. Well, I'm going to pick that. And even though it has an elevation, it's going to allow me to change it if I want. As soon as this unholy thing comes back. And the target, see, select the slope target. So that's the existing ground. And let's say I'm going to go 4 to 1s and 4 to 1s. Now, do I want to adjust those and redesign the pad? I'm going to say no. And now you see it shows me with a little bit more clarity, these little, red and blue lines. Those are the side slopes. And they're nothing more than just drawn line work that I would also use to help build that surface when I, isolate those layers. And I can see that my red lines are in areas where I've cut down into the bank. The blue lines are in areas where I filled to get back down the bank. Okay. And I would just do it in this fashion. I would isolate that layer. I build a surface out of this and call it a day. So that would be the process. In civil, though, once I have that done, let me see. I don't know that it will do this. It might. If I have the civil module and I go to my surface menu, I now have an edit pad template. So if I do that and then choose that pad, yeah. So it reads it, it says it was created with 4 to 1, 4 to 1, and this elevation of 1314. I didn't really, that was my first guess. So I didn't really know what it was going to be. One of the things down here I can do is to balance that side. So if I choose balance, it lets me know, okay, give me so within the nearest 10 yards. Now, what do I want? A balance import to match the export. If I say 0 and 0, that means they have to equal each other. But maybe I'm designing a borrow pit in this area, and I want to make sure I've got enough cut into the hillside there to get, say, 15,000 yards of dirt that I need for something else somewhere else. Okay, so you would say in that case, I want to, bring 15,000 yards, and it would calculate where that's going to be. So if I say, okay, all right, that then is be the way, and it's all in cut. See the red lines? And the elevation went from 1314 down to 1302.74, right? If I say, oh, well, yeah, maybe that's a little too close. So I could say, let's remove this vertex. And now I'm going to hit process. And that'll pull it back in. Now, when I do report, it's no longer balanced even at that 15,000. So that cut it down to 13,366. Okay. So if I did want to then balance it as well, we'll try to balance this again, and I'm going to leave them at 0 and 0. And you see now it's about half in cut and half in fill. And I've got up here, you see 750 cubic yards of cut and 750 cubic yards of fill. Basically a net sum game of 0 to bring this about. Okay. Everybody sort of get a sense of what's going on. I've got a tool that let me build that surface called EG1 that fills in the gaps between contour lines, fills in all of the missing information. And then I've got other tools that are going to allow me to set elevations on things and set where they intersect with these data sets. And then once I have those, I've got another set of data that I can use to build another surface with. And then I just compare one surface to the other, and it calculates volumes. It does what I've been doing here with these edits. So it knows all that information because it's got something to compare with, and it's comparing it, against itself. But I can build a surface out of, all of that stuff. But, and there we go. Oh, and by the way, one of the buttons there said write the 10. So I could have, instead of doing it this way, of say isolating it, I could go back through here to build this into another surface by itself, or I could have just hit the button as part of that tool that I had up there a minute ago. Either way is fine, does exactly the same thing. And oh man. But you can see and get a sense of this pad that was sort of cut down in the back side of the hill and then leveled out by filling in the front. Okay. Restore that back, and that's got that. Now, I know that's a lot that has come at you really quickly, but I can just try to reassure you and promise you that it will make sense and it will be a lot easier and it will be second nature in no time once you start working with these things. Okay. So for now, it's 3:05. Let's take a little 10-minute break and come back at 3:15 and wrap up the day with some many questions, and we'll see how much we can get done on that little work exercise that the exercise is called putting it all together. I'll show you a couple of other things that you can use to consider when you're building surfaces and working with them. Okay. So until then, does anybody have any particular questions or sort of starting to get a little bit of a glimpse under the hood as to how this stuff is working and what's going on? Okay. All right. Cool. All right. So I'm going to, I'll save that file. I will turn my record player back on. And yeah, we'll finish things out. If you've got any questions as we go through this, we'll talk about them as we encounter them. Now, we built a surface. We built that existing ground surface from that big complicated file that was that sample from T3 Global. And there's other things too that sometimes we just have points. We don't really have anything else. We just got a bunch of points and we're going to build some files and maybe compute some volumes. And so here's how the exercise on page 37 in your manual is going to start out. They want you to open that file called example one. We have one. I can restarted things. Let's see if it's cleared anything up. Also switch back to the 2024 version. Okay, finally. Oh, open. It recovers itself here, and it's going to be this example one. And this is going to sort of touch on a lot of the things that we've covered here so far. We've got a drawing that has a bunch of points in it. Now, this is new with 2024. It says it has this projection of State Plane 83, Alabama East. Currently used in this drawing. We're switching to a less ambiguously named projection system. Would you like to specify it as USA NAD 83 2011 Alabama East, which would not cause any drawing transformation to occur? And I'll say, yes, go ahead and do that. NAD 83 2011. And off it goes. And it gives me a warning about annotation scaling with older format files, which I can ignore for now. All right, so now I've got some points. I'll even do the old style change, which under my text styles, P text, I just really despise that font, which is completely stupid of me because it's actually a pretty fast font. But anyway, there you go. Me being an engineer. Now, what do we have? If we look at this, I've got basically a series of Carlson points. I've got point numbers. I've got elevations. I've got descriptions. And I really see two descriptions, B and B dash toe. And it's really like the toe points are looking like the toe of a slope, whereas the B points are the non-toe points. Now, what do I got? If I'm going to, I can build a surface out of that, but I've got a couple of things that's going to be, building long, skinny triangles in here. So I need to sort of do a little bit of upkeep on this before I jump into that effort. What else do I have? Look at the top stripe of the drawing. And it says I'm running Carlson Survey 2024. Coordinate file, none. I've got a drawing file called example one that had these things in it, but where's my coordinate file? I don't have a coordinate file existing for this. How would I create a coordinate file and get these points in it? Do you remember?
In the points tab.
Yep, we're going to come up here and do what? Talk me through what you would do if you needed to create points into a coordinate file, but you only had them in the drawing.
You would do set coordinate file.
Okay, I could set a coordinate file. And
New.
yeah, so I'm going to say new. And you
And
could
then
same name if you want. Or you can give it a different name. In fact, I'm going to give this a different name just to be contrary because this happens to be a stockpile. I'm just going to call this stockpile.crd. Okay, so So now I've set that coordinate file. Did I get the points into it yet? How could I verify that, whether I did or not?
Good,
And
go to point list.
yes, so I'm going to list my points. Let's use all. Say okay. Oh, it still says 0. And guys, when I'm doing these questions here, I'm not trying to put anybody on the spot. I just want you to sort of think out loud so I can hear your thought process and sort of guide you into what you're trying to think. So remember earlier we did that little exercise where we had to update the drawing from the coordinate file or update a coordinate file from the drawing? Remember that sort of vaguely? And it was, again, on the points menu. And those were some point utilities. It's either on this menu somewhere here on this, or this nice big overall sort of handy duty Swiss Army knife thing, which there in fact is that icon, coordinate file utilities. And so now on a file basis, so I look at these buttons on the left and I see, very bottom one, update the coordinate file from the drawing. So wildcard description, I'm going to say take all of them, just anyone you find. So I'll leave that as an asterisk. That's a wildcard. And I'm going to say, okay. And it says, okay, select any Carlson, Land Development Desktop, Softdesk, Inroads, Eagle Point, Geodometer, Leica, or Microsurvey points. Select entities. Well, these are Carlson points, but they're just not in my coordinate file yet. So if I select them here and hit enter, it's now brought into points, and see it tells me right up here, the highest point number is now 2079. It tells me down here on my command line, I brought in 240 points, found 80 points. It's actually 80 points, not 240. It found 240 items. Remember, it's a graphic block, which is the symbol. It's the attribute block, which are the labels, and it is the point entities. So 3 times 80 is 240. That's what it's telling me with those numbers. So if I want to verify this, here's that list points again, very same command as if I took it off the menu. So I'll say okay, and I say, okay, now there's some B toe points and there's some B points, and I see down here I've got indeed 80 points in there. All right. Now, the other thing I wanted to let you know is that I just did that to be able to capture those points in a coordinate file, but I didn't even need to do that. I don't have to put those in a file. I just did it so that if I ever need it again later, I have that for my use. Let's create a border. Let's draw the boundary around this point, around this set of points, which is basically going to be the bottom of the slope all the way around my stockpile. And these are the points that say B dash toe. So what can I do if I wanted to just look at my B dash toe points? What would be some things? Remember when we looked at, say, the property corner points with their little example? We had building points and edge of pavement points, and we had property corner points. What mechanism did we use to get those? Remember we called them point groups, right? So if we go up to our points menu and choose point group manager, we don't have any groups in here yet, so let's make some. So let's come down here and hit our create button, and let's call these, I'm going to call these perimeter. So these will be my perimeter points. And instead of including all, let's go here. Let's see if I uncheck include all. No, let's include all, but let's exclude by description just plain old B. Save. Now remember what I did there is we looked at all our points. The only descriptions we have are B and B dash toe. So when I built the group called perimeter, I had said use everything but exclude the B points. There's B dash toe. All right. I'm going to make another group called interior. Don't necessarily need to, but just because I'm here. I will uncheck include all. By description, I'm just going to get B. Now, why did I not get B dash toe is because when I said use B, when it's looking for another description is B dash toe, I would have to say B asterisk. So it means a B and the letter B followed by anything else. That's my wildcard designation. You can also use question mark, question mark, question mark to get individual character replacement. Okay, just like file name substitutions. So I now have interior points and I've got perimeter points. I'll say, okay, all right, so they're there if I need to use them. In fact, if I only wanted to see these perimeter points, let me see if I can freeze points. Yes. If I say I want to freeze points, now these points are all on the same layer probably. I'm going to selection method. I'm going to select, say, well, I could do a selection set, but let's just say a range of points. I'll say, look at all the points, but I'm going to say, instead of all the points, I'm going to use this point group, and I'm going to freeze these interior points. And I'm going to say, okay. Or I could have said description match and just said B. All right. So, but I'm using the interior points. Freeze the symbols, line works, and text. Boom, they're gone. They're frozen. They're still there, and they're even still in the drawing, but they're frozen. They're placed on a temporary layer in memory and frozen, and then they'll bring them back later when we unfreeze them. Now, why did I do that? Well, that was to be able to draw a line around all these things and ignore the other points in between here. So if I didn't, let's go back to points and thaw the points. And if I do that same type of thing I'm getting ready to do, if I'm going to draw shrink wrap entities, surface boundary, medium reduction, say okay, and then select all of this data, right? So there's my boundary because it found the nearest points, but what did it do in certain areas? It went be toe to toe to toe to toe. Well, look up here. That point is not one of the toe points, that's a B point. So that really should look like this. Okay, so instead of grabbing that point, it should have done that. It also should have like right in here, not jumped up to there. And I think when you normally do this, there's one of the toe points that it doesn't get. Although it looks like that time it did. Yeah, I think we're okay with that. All right, um, so that's one of the reasons we like to use the groups is so we can manipulate those. So I said freeze the points, freeze the group called interior, and thaw them back. Use that to create this boundary. Now, this boundary is on a layer called surf boundary. Let's find that layer and make it a little more visible for you. So there's where it created that as an outline. Now, why are we going to do that? Because when we make this surface, I'm going to have this little inset area. And if I don't make this as a bounded edge, if I don't use that as an inclusion polyline, it's going to start building these long, skinny triangles out in here in this area. And I don't want that because I don't know any information about that. Same thing over here. It's going to start putting in these little triangles right across here. And I don't really know what's going on with that. Same thing down here. Okay. So without the boundary, I get triangles out there in those other places. With the boundary, I'm going to be able to limit those outside triangles. So let's go ahead and build this surface. If you remember how to do that, we go to the surface menu. We choose triangulate and contour. And this time I'm going to go to triangulate. I'm going to use the inclusion exclusion areas this time, and I'm going to trim the edges at the boundaries. Okay, and what is, oh, they've just moved these things around a little bit. They've got the triangulation file up at the top now. I switched up to version 2024 after the break. So I'm going to write the file. I'm going to choose select, and apparently restarting did nothing to speed up that file dialog. Oh, all right. So this time now I'm going to call this stockpile. And again, I'm going to uncheck, draw the contours, uncheck anything on these others. And I'm just going to save that file, use the inclusion. I will also densify any break lines. It's not going to help me any better there, but it's one of the things I can do. And then I'll say, okay, I'll now, it says select entities. I'm not going to grab everything like I've been doing in the past when we were working on this stuff. I need to read the line above. It says select inclusion perimeter polylines. So everything that I want to look at as an inclusion boundary. So I'm going to pick that red line that I drew. That's one. Any others? I don't have any others. I just say, okay. There's no exclusions. I hit enter to finish that. And now it says, okay, select the points and the break lines. Well, these are only points. So I'll grab all those points, be done. It's calculated. It comes back and says, okay, I wrote the file. If I look at that file, you can see there's just not enough information here really to give you a very good surface definition. Okay, because it's, it's sparse data, but that's all you've got. So there's not much else you can do about it. Okay. You essentially got those points and nothing else. And you can see what they look like with their 3D viewer. Instead of the surface file viewer, we're going to look at the actual set of points. See, so it's And it's a pretty sparse set of data, but again, it's what we have. All right. So there's your existing surface that you've built, and it's just like from in your book now, you're going to see there's those boundary points, and we built our surface from there, and there's what it looks like. Okay, we haven't drawn the contours yet, and that's going to look like these red and blue contours here. Okay, so let's do that next. In fact, I'm going to freeze the layer that these points are on. I don't need those points to be out there at all anymore. I could even erase them from the file, but I'm just going to freeze. So I'm going to choose my icon that says freeze by pick. And I'm going to come down in and just freeze, actually. Let's freeze my selection. There we go. All right, so now I see where, and there's my boundary. I'll leave it on just for reference. Okay. So we've got a surface. What do we do if we want contours? Because remember the command that we ran has always been called triangulate and contour. And I've told you to turn off drawing the contours. And that's because you can always come back and draw the contours to this at any point. Okay. You can, because it will read the surface file. So let's go to that part of the command under the surface menu, and let's say contour from tin file. And it's going to ask me for that tin file. There it is, stockpile.tin. And we'll say open. And you're going to see the dialog box looks very much like the other one we've been using, triangulate and contour, except for that first tab is no longer there. This has triangulate, I mean, not the first tab, but the last tab. It's got triangulate and then contour and label. So there's no save or write a triangulation file. It's already been done. But I do have a use inclusion or exclusion area, but I don't even really need it if it's the same file because, or if I'm not trying to chop down the area where it's going to draw them, I'm going to say, go ahead and use, I'm going to say don't use it because it will stop at the boundary that exists anyway. Ignore zeros is on, densify any break lines. There's no help with any of that. I can turn that off. I'm going to go to the contour tab now and instead check that on. And I'm going to make sure it says contour by interval and not contour and elevation, but contour by interval. And I'm going to look over to the right and I see where it's asking me for some layers. So I'm going to have this layer called, let's just keep it simple. I'll call it, let's see, not index. We're just going to call these INTERMED for intermediate. And we're going to go for the contour interval of every 1 foot. And I'm going to check on to draw the index contours. And I'm going to put those on a layer called INDEX. Now those layers probably do not exist yet. It will create them for me in my drawing. I'm going to say no smoothing. You could turn smoothing on, but I'm going to turn those off. Make sure you uncheck hatch zones. Otherwise, it's trying to calculate colored zones. And I'm going to go to the labels tab now and turn on to label the contours. And I'm going to put these on INDEX, which is the same as the contour label. Standard style, INDEX, standard style, all, auto, 0.110. Let's see the label, text size scalar. That's for my contour label. Let's make that just a wee bit smaller, 0.08, not parentheses 0.08. And I'm going to check box down here. I'm going to uncheck these top 5 and I'm going to turn on to hide the drawing under the label. So basically just like those points on that map before with the wipeout, it's going to do the same thing with the text label. But if you do that instead of breaking the contours at the label, you don't want to break the contours. You want to keep them whole. And if you do hide the drawing under the labels, it's going to let you do some nice little cleanup with those labels in just a minute. And you can see that when it happens. So I'm going to say label the index contours only. Actually, I'm going to uncheck that. I'll go ahead and label all of them. Align the text with the contours, put them on the real Z axis. And then I can go to like every, let's try every 200 feet. To make a label. We'll see how many that gives us. Or you could choose label intervals and say none on the inside, 1 per, 2 per, 3. I'm going to go to distance back at 200. That'll be good. And again, you can load and save these settings if you wish. I'm going to say okay. And it's reading the file, and lo and behold, there it is with all the labels shown. Okay, so I've got a 400 contour. I've got a 395. I've got a 394. Now, those labels look awfully large. Let's maybe do that over again. I'm going to go up to settings, drawing setup, and let's see what that is set to be. I think I said, oh, it's at 50 scale. So let's make this 20 scale. So the text is going to be a little better. So my symbol plot size is still going to be 0.1. My text plot size is still going to be 0.08. And I'm going to come over here and make my LT scale to be 1. We'll say okay. And 1 to 20. Okay, so that made a mess out of those. I'm going to just redo them anyway. So here it is. I've changed my annotation scaling so that I can use some better labeling techniques. I got a mess on my hands, so I can do a couple of things. I can recontour that and tell it to erase the previous, or let's choose a command we haven't used yet. Let's go to Edit, Erase, and erase by layer. And let's select layers from the screen, and it's going to be, if I choose one of those numbers, that's the index layer. I'm going to choose one of the intermediates also and just hit enter. So it's intermediate and index, all items. I'll say okay. Boom, it's cleared it out. Now we can go back and redraw. We're going to say contour from 10 file. There's my stockpile. There's all of these things. Make sure my text height, there's my label, text size scalar of 0.08. There's 10, hide under the labels. All looks good. My label style standard. My distance interval, for whatever reason, went to 80. Let's put that back to 200. And this time, instead of, well, let's see what that does. We'll say okay. And that's a little bit better. All right, so we've got some labels that's going to help us do this. So what was I telling you about? If you use that hide the drawing under the label, what it's going to allow us to do is, you see this label right here that's sort of in an awkward spot. It's right on that corner. Maybe the same thing with this one up here. I might want to put it down here or up here a little bit. Well, normally I would have to do that, grab that number, slide it over, snap nearest, rotate it to match the rotation. But you got a tool under your surface menu under contour utilities that says move the label along the contour. And as long as you did not break the contour, if you just hid it, then it's going to allow you to do that. So I'm going to choose the command. I'm going to select the contour label to move. So I'm going to grab this 399. And as I move the mouse, now I don't even have to snap to it. You see my cursor is way over here. I can just move it to where I want it and it repositions it. I'll grab this one And I'll put it up here on this edge. I'll look and see if there's any other awkwardly positioned labels. Maybe bring this back from this edge a little bit. And oh, up here's a 402 that sits right on the corner of that one, so that's no good. I'll put that, say, down here. 403. Everything else I think looks all right. Maybe pull 400 a little bit. There we go. All right. Everything looked pretty decent. So that's the advantage of doing that hide drawing under the label. It allows you to do those types of things. Right. So now you've got a drawing that you're starting to build, and it's starting to look like I can I could have sworn I saw something different here a minute ago. Oh, right here. So, it's starting to look now a little bit more like what the exercise has done. I've got these contours um, as part of our base information. Now, what can I do with that? I've drawn contours of a surface that's called a stockpile. I can even look at that. We've done that already. But what about the volume of material that's in that stockpile? What do I know about that? Let's give a little freestyle thinking here. What did we use on the other project to compute the volume of that little pad that we were designing? We had an existing surface, right? And we compared it to our design surface. And we said, show us the difference between it, compute the volume, and tell us what it is. Well, we could do that same thing, except where's our existing surface here in this case? And you might say, well, it's the stockpile. That's the existing surface. Well, okay, that is, but the stockpile didn't just say, spontaneously form. It's a result of, say, a conveyor belt dumping gravel out there on the edge of my quarry. So where would the existing ground be in relation to the stockpile? What would it be in relation to the stockpile? Any thoughts? If I were to go up on top of the stockpile with an auger and I start drilling my way down through the stockpile, where would I hit the original existing ground? How about like right after I punch through the bottom of the stockpile, right? Now the top of the stockpile we know goes from the edges, uses all those points, and then climbs up and comes down the other side and goes back down to the other edge, and that makes the top of the stockpile. Well, what makes the bottom of the stockpile? Anybody? What did we build the surface out of? Remember, we're using points and lines. So if the top of the stockpile were all of those points that were along the inside, what would be the bottom of that stockpile surface?
The points on the the points on the outside.
Yeah, and I would go from the outside of one edge and I would look straight across to the other edge, and I would not look at the points in between. but it's only edge to edge. And that's as if I had, stretched saran wrap around all this stuff. And that's the surface that forms the bottom of all that stockpile. And it goes from edge to edge. It does not go up and down and all that kind of stuff. Now it does vary. It's got some slight changes in elevation, but that's the only thing that I know and that I can assume is that it's going to go from one edge across to the other, right? So that's the way to think about that. And then that gives me a surface to call existing. The stockpile is then going to be my final surface, and that lets me compute some volumes. Now, I tell you that because as a specific exercise, because there is a routine up here under surface that says, well, not in survey. All right, so if you're in civil, however, it does. All right, I'm going to switch to the civil menu set real quickly. And under that surface, you see I've got these volumes by triangulation, 1 surface volume, 2 surface volumes, or 3 volumes. Cut and fill utilities right here is what I'm looking for. This stockpile / pond / pit volumes. It's really nothing more than doing it the way we're doing it by using our noodle a little bit. We know that the bottom surface is the existing ground, and that's going to be defined by one edge straight across to the other edge without considering the stuff in between, right? But if you choose these, and if you look up the help system, you'll see it tells you you have to have the boundary drawn on a very specifically named layer, and you have to use grid sizes. It's really not worth even bothering to learn about, because once you know how to take 2 surfaces and compute a volume, that's the most accurate way to do it. And you can do it that way, whether it's a stockpile, a pond, a parking lot and building, a subdivision, it doesn't matter. Once you know the fact that you've got 2 surfaces, off you can go. And in fact, on this one, it said you can even do the volumes by triangulation, 3 surface volumes, and that lets you look for a particular strata of, maybe top of rock or something, or bedrock, or if you're in a strip mine area, the top of the coal or something. But there's no need to have a specialized tool to do that, because you can do those on a surface by surface by surface by surface basis, as many as you need, as long as you just keep track in your mind which one fills the role of existing and which one fills the role of final at any given time. All right, so that's really the best way to approach this. Okay, so we talked about the existing surface now being one edge straight across to the other edge and not looking at the points. So how do we get that out of this data set? What all do we have in this drawing? We've got a bunch of points, right? And they're on a frozen layer. We'll switch back to survey. So if I thaw that layer, there's all my points. Now, what if we built our surface by using only the B-toe points? And again, we're going to still use this boundary object to trim it out to match the edges. So that would be, our shrink wrap entities. One of the things that we could have done, by the way, was to use, and this boundary that we drew, when we drew it, we just said use it as a 2D polyline. Well, I could have created it as a 3D polyline, in which case I could have just simply used that one item to create the surface, and it would have been fine. Okay, so a couple of ways to get to where we're headed from what we're doing now anyway. Let's go back and freeze the points because all the points are all on the same layer. Let's still go back and go to the points menu and choose freeze points. And this time we're going to make sure we choose that point group. And the one that said interior, we'll say okay and okay. So now we've only got the points out here that we're looking for. I also don't want to have my contours and labels for my stockpile out there showing because when I go to select my stuff, I don't want it to read one of those contour lines. So I'm going to say, let's isolate now from here. We're going to isolate. Ugh. So view, isolate layers. We want to make sure we get the boundary and let's get one of those veto points. Why? I isolate, I get the boundary. Boy, I sure don't know why it grabbed it did. Anyway, I missed this. So, excuse me. So now I've got this, and I see that it is a bunch of points at elevation. There's my 2D line. Oh, I'm sorry, we've got a chat going on. Oh, I'm seeing here. I'm sorry. If you guys had been answering these by the chat, I've been missing that. So, yeah, so you'd said you could isolate the points, use the point groups. Okay, very good, very good. That reassures me a little better. Sorry about that. All right, so um, a couple of things we can do. If I've got these points at elevation and that 2D line, if I want to make that a 3D line, I could, if I have the civil module, I can say 2D to 3D based on points. They could have drawn that up there. Or, and I'm going to come back to this in plan view, I could say, there's really no way of doing this after the fact. Let's just select that one and delete it, and let's draw it again. So I'm going to draw shrink wrap entities, and this time instead of 2D polyline, I'm going to say 3D polyline. So no difference other than that. I'll say okay. Select all of my points, and now see the line is at elevation. So that's a nice 3D polyline. And at this point, I can say, let's go back to points. Well, first of all, let's restore our layers and let's go back to points. Excuse me, thaw the points, and let's now freeze the layer that's on. So if I freeze, let's see, if I freeze, I'm just going to go to my layer manager. I'm going to find this master level points instead of point mark, point number, etc. I'm going to freeze that. Okay, so that should freeze all of our points. There they go. And I've got, in this case now, contour lines, text, and that boundary. The existing ground is going to need to be made from this 3D line work, and all of these triangles are going to form just from one edge across the bottom of it to the other edge. So I'm going to go to my surface menu triangulate and contour. And this time, instead of, I'll go in the triangulate tab, I'm going to click on to write the file. I'm going to, instead of using stockpile.10, I'm going to hit select, and I'm going to call that one base. All right, so the only other thing I'm going to do here is I'm going to check on to use the inclusion exclusion area because I've already got that nice boundary drawn. And I'm going to densify the break lines every 10 feet will be fine. I'll show you why we're doing that in a minute. And I want to uncheck draw contours because there's nothing that I need to know the contours across the floor of it from. But I'm going to draw the triangulation lines just to show you where the triangles are going to form. So now I'm going to say it says, okay, select the entities, or it says select the inclusion perimeter polylines. So that's this guy here, the red line. I'll hit enter and it says, all right, now select any exclusion polylines that don't have any excluded areas. So I'm just going to say enter for none. And now select the points and break lines to triangulate. Well, the only lines that I have, and it's a three-dimensional line, is that boundary. I'm going to select it, and it's going to step through every vertex along its length and start looking around itself for other points that it can create a triangle edge to of the things that I select. And the only thing I'm going to select is that line. So I'm going to hit enter. And now you're going to see it draw those lines. And they're going to be formed from edge to edge across the bottom. And again, it's not, 100% totally accurate, but that's as best we can do. See, that forms that base. So now what would I do if I wanted the volume of material in that stockpile? How do I calculate that? Oh, by the way, I'm going to erase those triangles. I'm going to use what command, anybody? How about erase by layer? And instead of leaving these in here, keep your eye on that because that's there purposely. It's going to keep the last thing you've used in case you want to use it again if you're doing, sort of iterative design. So I'm going to hit the clear button, select layers from the screen. I'm going to select one of those triangles and say, okay, now that's cleared that off. All right. So now I've done that. I've got two surfaces. What's the volume of material? Where would I find that command? First of all, what menu would I look under if I'm looking for volumes of surfaces? Would I look under Kogo? You guys can unmute your mics and speak if you'd like.
Is it under surface?
Correct. Yeah, I mean, even if you don't know that it's there, if you know you're working on things that have to do with surfaces, because you're looking at volumes between surfaces, why don't you start there and see if you can find it, okay? I know that you don't know where all these things are, okay? I'm not trying to put anybody on the spot. I just want to start to stimulate your thought process, all right? That's what I'm after here. So I want to look for, there it is, volumes by triangulation. I can do it with one volume or two volumes. Now, I made a second volume. If I've got an option that says one volume, why didn't I do that? Well, let's look at what that is and what it does, and let's talk about it. I've got one volume stockpile, okay? What can I do with that choice? It used to be this was our only choice. It made me choose a reference elevation. So I would basically need to know the average elevation of the base. But if that stockpile is sitting on the side of a sloped hill, that's not going to be very accurate, right? Unless I got an exact average, then it might be for the amounts that it was over, it's balanced by the amount that it's under, right? So that was one of the options. But look at the other option right here. Use the 10 perimeter as the base. Well, that's exactly what we're just doing, what we just did before. So now that you know it's exactly the same thing, you could certainly, use that as an option to compute. But because the process is slightly different, I want to think to myself, well, I'm always going to be looking at two surfaces. So I don't need to worry about that as an option. The only thing extra I have to do is build that second surface. But in any case, let's just compare the results. I'm going to say use this as a 10 perimeter. I'm going to say okay. And you notice it said some things over here that went by in the command history, loaded so many points and edges. And I'll just take these and have none of these options checked on. I'm going to say okay. Here's my numbers. I'm going to just dump it straight into the drawing with this output to screen. Again, take those defaults and I'm going to put them right here, hit enter to set its rotation. So there is the first option. I've got just a wee bit of cut, 1.7 yards, and that's where there's a little bit of a turn up on one of the corners down here. It's really negligible. So basically 3,200 yards of fill. Okay. Let's now compute the volume by triangulation using two triangulation surface volumes. Now read up here at the top stripe what it's asking for. It wants to know the existing surface. That's the base. Comes back immediately and asks for the final surface. That's the stockpile. Okay, select any inclusion polylines or enter for none. I'll just say none. No exclusions. Again, none of those options set. I'll say okay. I'll dump to the screen and we'll compare the two. And this is going to go right in here just for yucks. And you see it's slightly different. Okay, it's essentially 3,200, 3,250, something like that. 3,265 versus 3,275 yards of fill. Now, the reason there's slight differences here is because it is using with this one volume surface and the 10 perimeter, it is calculating that one using a gridded approach. So it's a little bit less granular. It's really all relative and fine because you can see this number here. I need to change the elevation by 3.5 feet. I need to push it down by 3.5 feet to make it balance 0 to 0. But really what I'm after is I know I can sell my stockpile of coal that I've got sitting over here. I've got 3,200 yards of material over there that I can do something with. Okay. So pretty decent little approach to things. Now let's do this. Let's do let's cut a borrow pit into our surface, into our stockpile, and figure out how big we need to make that into a borrow pit. How deep do we need to plan on cutting it out? Because we may need, let's say we're going to need 5,000 yards of material somewhere else. Okay. So let's get busy with that. Let's go to our view layer control and we'll make a new layer. And I'm going to call that pit dash BDY, pit boundary. I'll make it yellow, and I'm going to make it a little heavier again so you can see it. And I'm going to double click to make that my current layer. And now I'm going to draw something that looks sort of like what you saw there before in the book. So I'm going to go to draw 2D polyline, and I'm going to say just use the current drawing properties. And here's one thing I could do. You see this elevation? If I know the elevation I want, I can go ahead and put it on there, but I'm not going to do that. I'm going to let the computer help me with that in a minute. I'm going to say, okay. And I'm going to basically say, I'm going to click back in this sort of upper area at the top of the hill. And I'm going to come across the slope here, sort of parallel to the back to this part of the hill. I'll come down and sort of come across the bottom. Let's see, somewhere in there, and then I'm going to type C to close. All right, so that's going to be what my borrow pit's going to look like now. What is a borrow pit, really? It's not a hill. What is it? It's a hole, right? It's a pond, sort of. So when I'm going to design this as a design pad, which way am I going to tell it to go out and seek either the ground or a particular elevation? Is I might say, oh, I want to go down to the inside of this pad because I'm going to excavate this particular hole in the ground. So you can sometimes you want to take this line that you've drawn and you want to set it at a specific elevation, and then you want to use that to climb up out of the hole and hit the existing surface as a target. And that's one way. Or you could set this as the outer edge, but you need to set that and then drape that on the ground and then go down to the inside at 3-to-1 side slope. Okay, so I keep forgetting not all of you guys have civil. Some of you are just survey. So we don't really have those 3D tools that exactly. Let's do this. If you've drawn your outline like such, let's offset that a little bit so I can get off this back edge. I'm a little bit close to that edge. So it's now a 2D poly. I can use the string, plain old regular offset. So let's go to edit, offset, standard offset. The option I want is through a particular point. So I'm going to grab, it says specify the through point. So I want to come up here to say maybe right in there, right? So I'm going to offset about this amount. And now I'm going to select that original outside one and get rid of it. Because I'm going to start actually down here at this elevation. And if I had civil, I would be able to do this and hit those adjustment factors and set those targeted ranges for my materials so that I can figure out how I'm going to address this. So for us here in survey, we're going to allow it to, we'll do as much of the automation as we can. We might have to go back and do a couple of iterations, a little what ifs and that kind of stuff, but I think this should work. All right, so let's go to surface and let's choose design pad template. And now the source, I'm going to come out, I'm going to start this thing at a particular elevation, and I'm going to use it to climb out of that flat floor and come up and hit this existing ground. So that's my target, is the surface file. Notice if I was going from the outside in, I would have a target. I would set my target to this option over on the right. That would be an elevation. Okay, so I'm going to go to a surface file, and I don't understand why. Oh, I guess I got to choose. I'm going to uncheck the multiple pad polylines. So now I'm going to go from, this is the bottom of my pad. So I want to go to the outside. Otherwise, I would go to the inside from the top down to a particular elevation. So I'm going to go to the outside, and I'm going to run corners, draw the side slopes, erase previous pad entries, and the colors. Okay, so everything looks good there. Trim the existing contours inside the pad. We're going to say no to that. Otherwise, it's going to start trimming off contours. But remember, we did a couple of those editing tools earlier this morning to, break at a crossing polyline or erase by closed polyline. So we could do all those things as we need to do them after the fact, but this will help you to do it. And right here, this one that I just turned on, calculate the surface and calculate earthwork volumes. This is going to allow us to do a little bit of this stuff automatically. And you can contour the pad, yes or no. I'll just leave it off for right now. Write the final surface. I will have it ask me to do that. The pad layer, I'm going to call this my pit instead of pad. And I'm going to say, okay. So now I'll pick the pad polyline. Right here it is. I select it. Here's my targeted surface called stockpile. I'm going to say open. Now the outside, when it's going to, in fill, I'm going to say 3:1. Then cut, it's going to say 3:1. Now, it saw that polyline that I selected. It read the elevation of 0, and it knows I haven't set the elevation yet. So it's telling me that, okay, along that polyline, the range of existing elevation starts at 396.05 and goes up to 404.31. All right, well, that's good information to know. I can confirm that by looking at the contours that it's intercepting. But what I would also consider myself is that if I'm making a borrow pit in this stockpile, I want it to be in cut the entire time. So I don't want to make it higher than the lowest elevation, because I'm going to have to fill part of that. So that wouldn't make any sense. So I'm going to say, let's take it from 395 as the elevation. So we'll be a foot below the lowest existing right now as a starting point. And off it goes. And here I see, okay, I have my 3:1 side slopes. My top of my pad elevation is 395, yada, yada, yada. I've got, what, 39,000 cubic feet or 1,450 cubic yards of cut. And what did we say we needed? 5,000 cubic yards of cut. So let's keep that part in mind. That's where we're headed. So I'm going to say exit. It said, you want to adjust the parameters and redesign. I'm going to say yes. Now, here's where it gives you that same thing. Now, you see those lines out there that it has drawn? That's my cut and fill lines. And it says, you want to balance the cut and fill. Well, yes, indeed, I do. I'm going to say yes, but it doesn't mean make them 0 to 0. It means make it whatever your target is. So within the nearest 10 yards, my balance import, I want to make sure I don't have to bring anything in to build this. But what I want to take out is 5,000 cubic yards. Now that may run off the back edge of the stockpile, but we'll see. Yeah, see, it said point is outside. It's off surface. Okay, so that would be a bad set of numbers. But you can see when it did that computation, it came up with 5,000 cubic yards of cut. Adjust, I'm going to adjust it again. Instead of making it quite so big, I'm going to, let's put it down to say 2250. A little better. All right, so there's 2259.46, 2250 for the balance export volume. And again, you could have different slopes, all kinds of different things. New fill, here's areas of 2250, so I'm okay with that. I'm going to say exit. Adjust the parameters and redesign. No, I'm happy with it now. Now, what do you want to do? You want to create a new surface. This is the final surface, or you can update the target, which was stockpile. I don't want to do that. I'm going to leave stockpile alone. I'm going to say create a new surface, merge the pad. So it made a surface called pad or pit or something. Or it hasn't yet. It's going to ask me to save it maybe. Now, do I want to merge that with the original target surface? Now, think about that. That would be as if I have a surface that has all of the existing stockpile that hasn't changed any, but it gets up to the edge of this borrow pit and it starts to incorporate that in as one continuous surface then. I could do that. That would not be a bad thing to do. I've got other commands that let me do that surface merging if I want to later, or I can just use these as two separate surfaces and keep track of what I'm doing with them. So I'm going to say no to that merging. And now I'm going to call this my pit surface. So I've got a stockpile, a base, and a pit. Okay, now I could also even, and I didn't have to because that command design pad template took this, which was the resulting 3D line work. It created all of that for me as part of that design. And then it said, or, do I want to balance? So it created all that and it wrote the final surface. I do not generally write those surface files as part of that. I usually will isolate this and build this individual surface. Now, if you remember, we took this bottom layer and we started at 395, remember, at a starting point? And now that we're balanced, I now selected that and I look over here and I see, all right, so it dropped it down to 392.81 feet. So if I take this stockpile and I come up here and I start digging this thing down to this elevation of 392.81 feet and 3-to-1 side slopes, I'm going to get my 2250 cubic yards of material out of there. Okay. We got two surfaces. Let's take a look at them. On your surface menu down at the bottom part, remember that little quick profile? I'm going to use surface file. Now this time I've got two places I can look. The first file I'm going to choose as my stockpile. And the second file I'm going to choose as my pit. And say okay. And it says pick a starting point or use a center line or polyline. I'm just going to click here and I'm going to go across here and hit enter to finish. Okay, so now as I move my cursor, look at the crosshairs in the profile view below. Let's put that, say, at a 1-to-1 elevations or exaggeration. So you can see the white line is the original stockpile, but I'm going to come in there and come down that front slope at 3-to-1, hit that bottom elevation. Now I'm at the bottom. Look over here on the right-hand side, and you see that I've got, well, it's tracking the elevation and slope, but it's tracking the first surface. So I need to probably consider this backwards. Let's go back and do that again. Let's exit. Repeat the quick profile, and this time let's just swap their order. So I'm going to hit for first the pit, and for second the stockpile. There would be. So now I'm going to go from, say, here to here, be done. So now I'm going to come down. So you see I'm at this side slope right in here of 3-to-1. You see over on the right hand side of my numbers that say slope of minus 33.1%. Once I get to the bottom of the borrow pit, I'm looking at 392.8, and it's constant all the way across the bottom. And it starts up the other side. Now that other side slope is 25.7%, not 33. So that's at a 4-to-1. But we told it to cut this at 3-to-1. And why is the reason for that? Anybody? How about because I'm not going up that slope perpendicular to it? I'm going at a sort of slewed angle. So if I really wanted to see that, I would say adjust this alignment. And I want to go down to there in that regard. And now when I'm sitting on there, excuse me, it's 33.3%. So there's my 3-to-1. So, all kinds of information it's going to give you. Let's take a look at, you can look at that in real time and see, how does it look for, what your intents are. So that's, a couple of nice tools. I'll exit. Oh, by the way, if you were curious and wanted to do something like this, you could come over here now after you use, all right, I want to see, can you plot me that out and let me see it? Well, yeah, just hit the draw button. Come over here to the side, or you can go through all of this setup. We don't have time to go through all that, but you can set your scales and your grids and all that stuff. I'm just going to say okay and take some defaults. I'm going to put it over here. It's likely going to have a weird exaggeration, but anyway, there it is. So you would, make them different colors and different styles and all that crap. And there's a 1:20 and a 1:5. So it wasn't that weird. It's about a 4-time vertical exaggeration. Okay, you can do it that way. You can also create cross sections and do all that kind of stuff if you have the civil module. But you still got a lot of tools with just plain old surveys you wouldn't normally even be doing with survey. So there's that design. Now, if we have, let's see, this is on a layer called pit. I'm going to put this on a layer called pit boundary. I want to get that layer. This one is also, it's on pit boundary. Well, I'm going to make a copy of this outside footprint there. I'm going to use that for something here in a minute as well. So I'm going to go to edit, copy to layer, select my entities. That's that one. And I'm going to put that one on pit boundary. All right, so there they are. I'm going to now freeze by pick the pit. Okay. So now what are we after in our design quest here? And you saw those lines and stuff that I just froze. And here's where we merged that surface into the existing stockpile. Okay, and you can do that. But one of the things that you can do, notice over here, see the existing contours underneath with these dashed contours? And these heavy solid contours are the contouring of that surface, the actual pit surface. And you could even do something like this where you've drawn the existing contours up to these design contours and stop. Okay, and then pick up the design contours and let them draw, where they are. So how would we do that with what we have now? Remember, we did not do the surface merging. And even if we did, we would have, these existing contours coming up here and, they would all be one finished contour because that would really technically be the final contours. And that is not wrong, but what we're after is to have a view of that sort of along these lines where we see the existing and they stop right before that final takes over. It could it could look like this. This is really more of a true grading plan where you see the existing intact and then you see the others over top of them. But let's go for this type of look. How would we do that? And we can do this very simply with tools you've already used. Okay. Let's go first to the layers menu, the layers. And look, we're going to set a couple of different layers here. I'm going to say a new item, and I'm going to call this layer, let's just go, let's just call it CTR dash INT for intermediate dash, let's see, CTR dash INT dash EX. So we're existing, that's good. I'm going to call another one CTR dash IND for index dash EX. Okay. I'm going to make another one CTR dash INT dash FG for final grade. And one more CTR dash IND for index dash FG. So I'm going to take that extra little dash out of the name. Okay. All right, so I got these, they're all the same, but I'm going to load up some line styles here. So my intermediate contours, I'm going to click, I'm going to make that color this, say this light gray, number 254. If it's too light, we'll switch it. The index on my existing ground, I'm going to make a little bit darker. So I'm going to come down here and grab the 253, make those stand out a little bit. I'm going to change their weight. The intermediates I'm going to make, instead of default, I'm going to make them really kind of skinny of 0.013. And the intermediate I'm going to make just say 0.18. Let's go back to go back to the 0.013 and let's make it 0.09. So there's a little bit more of a contrast. So 0.09 to 0.18. And now for the line style, I'm going to choose continuous. I'm going to click on that because I want to load up a particular line style. I'm going to hit load. And now don't worry about doing this because you don't necessarily know where these are on your system. But I'm going to load from this default. Mine says ICAD 11 dot whatever that LIN file. Okay, so when I'm doing that, it preloads those. I'm going to scroll down here and I'm going to look for a file type that I know is already built in here, and it's called Contour and Contour 2. And it's basically the dashes of a contour line, but it's not like dashed or like dash line styles. It's more of a, it's a longer dash and a smaller gap. So it looks a little bit more like intended for contours. I'm gonna say, okay, I've now got those loaded and I'll say, okay. And now my, my, excuse me, my intermediates are going to be the smaller dash, which is contour 2. My index will be the longer dash, which is contour. All right, there we go. So far, so good. Now, my finished grade, intermediate, and index, I'm going to make, let's go with the intermediate first, and we're going to put them as a color of, let's use this sort of color 31, sort of tannish looking. And we're going to give it a weight of, let's say 0.25. We'll keep it continuous. And the index, we're going to make it a little brighter, say of 30. And we're going to make it heavier instead of 0.25 or default. Let's go with 0.40. Okay, now we've got some things set up ready to give us some things. We're going to erase by layer. So edit, erase by layer, those existing contours. So intermediate and index, and we're going to redraw those layers, those contour lines. Now, remember when we draw, we say contour from a tin file. Let's take from a stockpile, and I'm going to draw the contours. And I'm going to put these on, this is my existing, so it's CTRINT existing, it's my intermediates. My index are going to be on CTRIND and EX. All right, and then labels, I would put the label layer on CTRINDEX. Same thing here. And I would say, okay. And just take the defaults of none and none, and it's going to draw those in like this. Oh, let's see. I need to now edit, erase by layer, clear from the screen, get those triangle lines. And what happened with that was when I did this command, contour from tin file, I forgot, and we did that the last time. So we opened this up and we had on this tab here, we said draw the triangulation lines. All right, so I don't want to do that. Sorry. So now we've just basically drawn this. I'm going to set a couple of variables. I've got MS LT scale. That means use the master or the model space LT scale. I'm going to turn that on. And I'm going to set my LT scaling to be 1. And I'm going to then do a regen. And there are those lines. In fact, I'm going to say LT scale equals half. I'm going to make the things a little bit tighter. All right. So that looks like those. I see this index. You see the dash is longer. The color and the line weights are not all that differentiable. So I'm going to adjust those. I'm going to look at CTR star only. So 254 and 253, let's make the index 254 and the intermediate 252. I think if we do it in that direction, that would be good. And we'll make that 0.05 compared to 0.2. And now for these, let's swap those around too. So that's going to be 30. And this will be 31. And we'll go with 0.3 and 0.5. So now you can start to see a little differentiation in those particular lines. Now, remember what we did earlier? And I promise, guys, we're going to be out of here in just a second. And we're going after this look down here where we've used this to sort of cookie cutter out those existing contours. All right. Excuse me. So you can, based on what you've already seen today, go to edit and say break by crossing polyline. And you could say, all right there's the clip that I want. And which lines do you want to consider to break? Let's just grab them all. And you want to specify the layer name for the inside segments. Let's say yes, and we're going to call that INSIDE. Outside segments, no. All right, so now I've got those. I've kept those. I could then freeze this layer. And it looks like and I could put those there on that layer on the inside too. So that's one way of doing it, right? I could break and choose those that way. You've seen that, but that actually physically modifies those contour lines. Now, what else could I do instead of that? Well, if I erase by layer, I'm going to get rid of those contour lines that we've drawn so far. And labels, because I remember I still have the file, and the file is complete. It goes across the whole thing. So I would say, let's go to surface, contour from tin file, and this time watch what we do. Let's do the stockpile. And we're going to say everything like we did before, except I'm going to not label quite so many. I'll just do the indexes only. Using inclusion exclusion areas. Now watch how this behaves. So if I say okay, it says select the inclusion polylines. Well, it's that one. That's everything inside of that would be, I didn't even need that because the surface, there's no data out here. So I'll hit enter, and now it says any exclusions. Well, if I choose this first edge, that's going to be that original trim line that I did. And I'll hit enter. I want to keep neglecting to uncheck that. So let's just clear, select from the screen. That's only, I don't generally draw those things. So now there we're looking like we where we're headed here, like that. Okay. So the next one that I want to draw, the next surface that I want to draw So I say surface contour from tin file is that borrow pit. Same thing, except I'm going to uncheck draw this. I'm going to also look at these different layer names, and instead of EX, I'm going to type, just select these and change them to FG. What else? Excuse me. All right, that's it. So now it wants me to do the inclusion and exclusion. So if I had merged that into the overall total, I could restrict the inclusion to just be inside this line. But remember, we did not do the merge. It only goes out that far anyway. So I don't need to worry about that. I'm just going to say enter and enter for any exclusions. And boom, there's those. Okay. And then I can freeze those boundaries. And there's, as they say, Bob's your uncle. And you see how those contours tie right into those existing contours because the surfaces targeted those as existing surface. All right. Now, with that being done, that was basically getting us to just sort of think through that process. When it asks you for things like inclusion and exclusion, I know users that because they don't be bothered with all that kind of stuff, they just bang, 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 or they don't ever use them. But you can see why you might want to sort of restrict what you're looking at within this particular area. And it does not always have to match up with the boundary, the outside boundary of a surface. I could have said only do all that in this upper left-hand corner, and it would have very neatly stopped all of that drawing up right over wherever I told it to turn that off. Okay. But this is, excuse me, a bit more. Now, I would probably, if I were turning this in as a, finished drawing to somebody, I would probably come in here and cut out these two little segments here and connect this little gap across there. I don't, well, no, maybe not. I'd have to take a look at what the original, maybe that does go off here. Maybe that is correct. Anyway, you get the idea. You would be able to play with that kind of stuff and use this around. Now, I still got that command that I had. Move label along just to get it off that sort of awkward looking place. So there we go. Now, so that gives us, or that gets us to sort of where we are going to be here. And the next thing we're going to do, and we will not do it today, I will leave this for your fun at home. I will tell you this, Gretchen, I know you have the civil module. Lane, what about you? Do you have the civil module or just survey?
Yeah, I just have the survey one.
Okay, so I know Storm, you've got the survey OEM, is that right? Who has the OEM?
I do.
Okay, so you two have survey only. Gretchen, you've got civil. So you got a few extra tools, but this exercise, I'm going to talk you through it. Excuse me, instead of having you sit here and go through it or watch me click, click, click. What you're going to do, or what the rest of the exercise wants to do, is you're going to design a road into this borrow pit area. So you're going to design a road up across the face of that stockpile. And so the only tools you have in survey come from the centerline menu, so you can design a centerline or you can draw a polyline to be a centerline. And then you've got a couple of labeling things that you can do, some right-of-way stuff, and that's about it. Then you have under surface, you've got these profiling tools. So you got some profile design you can do. In civil, by contrast, you've got a centerline menu that where you can do all kinds of additional things. You've got a profile completely separate menu, and there's a design road profile, which is sort of a souped up just profile editor, which is what you have in survey. And you've got an entire section of cross sections. But even more than all of that, you've got under the roads menu, you have this road network, which is incredibly powerful to be able to do roadway design. Now, that's a little bit overkill. You don't really need it for this, but if you do have civil and you do the occasional road design, you're probably going to learn to do everything through road network, even though it is, uber powerful. It's not going to hurt anything to use it. You're just going to get that much more out of it. Now, that being said, those of you who only have survey, what do we do? Because in our civil world, when we have the road tools, we're going to be able to stipulate a roadway center line, and then it's going to automatically go through and cut the existing ground into a separate profile there, and it's going to draw us our vertical, the profile, and then we're going to say process, and it's going to know what the cross-section template is going to look like, and it can have curbs and multiple lanes and ditches and all those different kinds of things. But for us, because we don't have those things in survey, we're going to do the center line, and it stays flat at 0. We're going to use it to cut a profile of the existing ground, and we're going to save that and give it a name. And you see up here it says pad access.pro, and then we're going to start to design this road a little bit on the manual side of things. And this is just the center line, and you can see as it comes across the stockpile here, and remember it's vertically exaggerated, it comes up here and gets to the top of the bank and then comes down to hit the elevation right here, this downward flank. That's where it hits the elevation, the bottom of that borrow pit. Okay. So, whoops. So there it is. It comes up, goes through some true vertical curves and comes down here, and it's going to land right there at the bottom of that borrow pit. And we're going to, do the cut and fill and all that to be able to get the road up. Now, once we have that done, we have a center line, which is at 0 elevation. We have a profile, but we're also able to draw that profile as a 3D polyline. And that's right up here with number 9 at the top. Okay, so you've now designed it, but you want to draw it. So we're going to use that to help you grade the roadbed. And so you're going to go to the surface menu and go down to the bottom of the profile section. You say profile to 3D polyline, and you're going to, choose the appropriate things you've done. And it's going to create and draw out there for you this 3D polyline that is right running with the center line of that road, and it goes up and down as it needs to for the road design. Now, how do you set the rest of this as a road corridor? Well, you've got that center line, and the road lanes might need to be, say, 10 feet wide on each side, or 20 or 45 or whatever they happen to be. So I'm going to take that 3D polyline and I'm going to offset it, one to the left, one to the right. But you can't offset a 3D polyline with the standard CAD offset command. So you're going to choose in number 10 here, 3D polyline utilities, offset 3D polyline, and you're going to choose the method to be by interval and slope projection, perpendicular to the polyline, et cetera. Press OK, and you're going to put, you know, a -2% cross slope. So you're saying put that center line as a 3D polyline in your drawing, and then offset one side and the other side by interval method a certain distance and a certain slope, and that's going to set the other edge of pavement. Okay. And then once you've done that, remember how we did the original pad polyline? We drew the outline of the pit area, and then we said, go from this outside edge and go outward and seek the existing ground. Well, you do the same thing, but you're going to use these outer edges of pavement. Now, they're not closed figures. So the only difference that it does is instead of like with our pad where everything was closed and we told it to go to the outside, in this case, when we have this offset line, this lighter blue line, and we say run design pad template and seek the original ground, it's going to stop and ask us which side to offset. So you know we're going to the outside of that. We're going to this side of this one. Okay, so we're projecting those slopes, you know, in a particular direction. Once you have that, just isolate those things, build a little surface out of that, that's your proposed roadway. And you see, you can now then draw the contours for your proposed road, just like you did for the, you know, for the borrow pit. And you can even incorporate that into the same single surface file using triangulation file manager. Okay. So go through that when you get a chance on your own to see how it behaves and works. So, I think you'll find it as the basis of everything you're going to be doing, particularly if you're going to do any type of grading design or you're going to need to set something. Let's say maybe even as a surveyor, you've got, well, okay, here I've got a 3D polyline that I was the edge of my roadway or the edge of my parking lot, but I've got to set 50-foot offset stakes. And I'm going to slope stake this thing around. So you can do all that and give it a projected slope away from the feature. And as long as you've got those other items, those other targeted items like a surface that it can seek and come up with, it will do the computation for you. All right, so it's really going to be helpful. Now, are you going to remember all this next week? Probably not, but you're going to at least know that you've seen it, and you're going to start looking around, and you're going to say, well, I really need to remember and I can't, so I'm going to send Ken an email and hope he doesn't get mad. And I told you when we started, I'm not going to get mad. Send me the questions so that I can help you out. And that's our greatest reward, is to get you folks to a point where you can think through that process on your own. I've got a really great client who's been a great friend for a number of years. I've known him for about 30 years. And, you know, he occasionally calls me up, but now the questions are really deep and obscure, and I have to usually do some research, but then I don't hear from him for months. And because he's learned it on his own. And so that's really, really rewarding to see how he's picked up on that. Okay. So with that, and the fact that I held everybody up 45 minutes, let me ask you as well, is anybody a registered, you know, a PE or a PLS?
No, I am not.
Okay. Gretchen? Uh, or let's say the better question then is actually, does anybody need continuing education credits? Okay, because in the state registration boards, you know, for surveyors and engineers and architects and such, we have to have so many credits of continue education each year. So you'll get those continue education credits. You'll get certificates that have all that documented. We keep a permanent record of it for you as well, but you'll get the credit for the extra time spent for the overrun today. So if you can use them, if not, well, it's just a nice little piece of paper you can put on the wall and throw darts at. Okay. All right. Before we go, any particular questions? I keep missing this chat button, folks. I'm really sorry. And okay, I see you got them in there. You're answering some of those. All right, good. Your mic died again. All right. Yep. Actually, yeah, very, very good. I think you got a good handle on that kind of stuff. So with that, as the starting point and the little seed to get you excited with it, take that, keep this handy, keep this at your side. Remember, there's all of this command reference in the back section after that exercise, and a lot of those things are taken straight out of the help system, but not, they're either taking those really verbose sections and throwing away all the extra crap you don't need to be wading through, or they didn't really document it enough, and so we beefed up some of the explanations. So but you know, it's there where things are there available with you. And maybe another couple of quick things to look at to keep in mind as a resource. When you if you go to the help menu, you've got your Carlson manual. That's the first line of defense. Okay. This sort of shows you, you know, some of these, and I can open these topic lists up, all of that, but here's my survey module, for instance. So if I open that up, I've got the survey menu, COGO menu, area and layout, annotate. So that's everything that becomes those module specific. If I say the general commands, notice it's file, edit, view, draw, inquiry settings, points, and of course help over on the other side. But those are the general ones and what they do. And you can go down, let's say points menu. And if I open that up and look at, say, draw, locate points, that is, you know, pretty exhaustively explanatory. And at the bottom, you know, it tells you the prerequisites and all that kind of stuff. So, you know, so use these as you need. All right. But here's the other thing besides just a listing of things in order. And that's more sort of like the training guide is sort of along those lines. But look down here at the bottom. There is a little lovely section called tutorials. Okay. And it covers everything, including CAD basics. If you're not very good with the CAD system, it's going to show you how to, you know, start it up, how to choose a new drawing. It's going to teach you how to select things, how to issue commands and command line prompts, how to repeat commands. So, you know, there's a lot of really good stuff in here to keep aware of. And then you've got these different things like entering a deed if you're doing any kind of work in the survey office involving deeds. That shows you that how to make a plat. Now that's more of getting the mapping done than it is deeds, but field to finish, intersections. Then you look at things like contouring and design, contour break lines, stockpiles. There we talked about some stockpiles, and there's examples, and they show you these examples, for instance, with this, say, a set of points, all of those are coming from sample files that you have in your, you know, your default installation gives you those as starting files. Here's another one, a dozen tools for surface design. Now, this is an interesting little approach because some of these are just ages old, and they may not necessarily be the best approach to things, but they're not wrong. Like you can draw these lines, draw a 2D polyline, design pad template. That's what we've been doing with this borrow pit. Okay, there's other things. You know, a bench pond, draw a 3D polyline, join nearest, offset. So all of these are different commands that we haven't really used a whole lot of these of, but they show you in a step by step basis. And if you come all the way down to, let's see if I can find some of these pictures here. There's right in here, they use polyline utilities. Yeah, so here's like a little valley pond, or not, yeah, valley pond on the other side, but you're putting a dam across a valley. So if you step your way through those, you can see you're going to get a lot of experience, and there's a lot of, practical pictures of how to do things. Calculate volumes by 5 different methods. Road design with volumes, road rehab, hydrology, and watershed. I'm not going to sit there and read all this to you. So they're all very good examples. And again, some of them might be using really old tools and maybe they've improved them, but the basic process is sound. So make sure that you use that and pay attention to it. Now, beyond that, you've also got on that same help menu this online training movies, and that just goes to Carlson's YouTube channel. And these are all down here under, various categories. And they've got, videos and playlists and the whole works. All right. And you can, in fact, when you get mine are going to be always posted as unlisted, but you can add them to your own playlist, etc. So look through these. There's a lot of them, but you can search, for keywords, and that will be very helpful for you as well. All right. And then finally, the last thing to talk about is I'm going to close this off. And when you're on this start page, once it decides, go on, Carlson. Come on, Carlson. I think it's come on Zoom. I don't think that's a Carlson issue. But there we go. Good. Heavenly days. All right. So when you're on this start screen, you've also got all of this stuff here in the lower left. And on the right-hand side, you got these tips and tips of the day. You can create your drawing any way that it's blah, 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 blah. You can scroll through those. But you have the access to Carlson support. You've got Carlson Academy. That's us. Some of you may have found us in that fashion. Knowledge base. So these are things that might be some sort of frequently asked question kind of stuff. But send feedback and Carlson support. Those are 2 means of getting directly in contact with Carlson, the software publishers. And they're really good about getting back to you. And it can be something fairly casual if you send in an email issue with a problem you're having. If it goes to that particular tech support email address, they immediately will open up a case number. They'll send you notification that they got it and that they're working on it and they're getting you scheduled, and they'll get back with you in a very short amount of time. And they're really good at that. So keep all of that stuff in your hip pocket. Keep all those resources at hand. Because really, the more of those resources that you use, the quicker it's going to settle into your bones. And I really hope you use it and you start to encounter successes with using it to the point where you stay excited about using it and you don't just throw up your hands and say, oh, I hate this. I'm going to just, draw it by using I'll just do it by hand on a piece of paper and then I'll give it to somebody else to finish. That's that's the wrong idea, because there's a lot of stuff this thing can do. And, you know, I hope you get excited about it as much as I typically do. Even with all of the, you know, the file drags and that kind of stuff. Okay. So before we go, any questions, any issues? Everybody good? All right. Hey, guess what? It's getting close to beer 30. Although I'm not much of a beer drinker, but I think I need another cup of hot tea to get my voice back. But go and enjoy the weekend. And again, stay in touch. Let me know what's going on. All right. So cheers. I excuse me. I'm going to send. I'll go ahead and stop the share here, and I'll stop the recording. But I'm going to send